Good evening, engineers. I hope everyone is connected to the internet and is available and present this training. So we would like to welcome everyone who joined us through online on this training. So I wanted to let you know that we are going to wait for 10 minutes while we are waiting for our colleagues to join the training. So everyone make sure that he or she has a stable internet and be patient while we are waiting for those trainees who are going to join us through online. Thank you. Hello, engineers, those who are following the training online. I think everyone is ready to start the training because we are going to start. So it's time to welcome Engineer Tejesh from Ashley, from again, Nziza is our instructor. So I hope everyone is ready to start the training. So Mr. Tejesh, take a floor. Then start sharing your screen to start the training. Thank you.
All right. First of all, welcome everyone. It's really an honor to be here. I know most of you folks are in the classroom today, but there is also some of the team members that will be joining online. So first of all, welcome. I'm really happy that all of you enrolled for this course. My personal motto is that knowledge should not be stagnant. It should always be flowing from one person to another, and that's how we make progress in the bigger end, right? So before we begin the meeting, a bit of housekeeping in case of emergency, that is the emergency exits for the folks online. Please locate the nearest emergency exits. Before we begin, I would like to have a quick check with all of the team members about their current experience as well as the job roles. So in the house, if all of the folks between 0 to 1 years of experience, if they can raise their hand. 0 to 1 years of experience. Okay, that's good. 1 to 2 years of experience in the field. 1 to 2 years, no one? All right, okay. 2 to 3 years of experience. No, more than 3 years of experience. Okay, that's awesome. That's good to know. Good to know. As well as on the online team, if you guys can please let us know in the chat box how many years of experience. It will help me better to go through the subjects as best as possible. Again, a show of hands, how many in the room are degreed mechanical engineers or have mechanical engineering background? Mechanical engineers? Okay. How many are electrical engineers? 2, 3. Okay, that's good. Any folks from other engineering backgrounds, civil engineering, structural engineering? Okay, that's good. As well as online folks, if you can please register your responses in the chat window, that would be very helpful. Okay, so without further ado, just Gorky, if you can close the doors, it's too much noise coming from the outside. Maybe keep one open. That's okay for now. I can speak from here only. Just one housekeeping item for the folks who are online. If you find it hard for you guys to listen to what I'm talking, please type it in the chat window so that our coordinator over here, Mr. Emmanuel, can let me know, and then I can adjust my position accordingly. So again, welcome to the MEP system design for hospital projects with Revit MEP 2025. I know this is an advanced course and there is a lot to go forth ahead with. So please bear with me as we go through theory topics, as we go through hands-on practical approach as well. The theory will be basically the basics for us to build the foundations for us to build our building, right? For a lack of better pun over there. I will also try to be slow in talking. I know most of us in the room, our mother tongue is not English, but since we have our mode of communication of English, I'll try my best to be as slow as possible. But in case if anyone has any issues understanding, please raise your hand. Please let me know. I will go through it again. The same thing applies for the folks online as well. If you guys have any issues understanding to me or getting in touch with me, please go ahead and type it in the chat window so that we can have the question repeated or the concept repeated. Also, one more thing, we are all professionals over here. We do brainstorming day in, day out. We also have collaborations happening with different team members like architects, general contractor, electrical contractors, so on and so forth, day in, day out. So I would be very happy if you guys also can contribute. I just don't want to make this a one-way session. If you guys have anything to share, any of your experiences to share, please make your voice heard. It will be great. As well as the folks online, it will be great to have your weightage as well. I know everyone doesn't know everything. So if you ask a question and I don't know, I'll make sure I say I don't know. But I'll make sure I'll get back to you with the correct answer as soon as possible. And as engineers, as professional engineers in the field of MEP, I think so that is one of the biggest ethos that we should live by, that if we don't know something, don't bluff it. Let the other person know that we don't know and then come back with the right answer. All right. Okay. So enough of housekeeping stuff. Let's move ahead. Let me give a small introduction about myself. I'm Tejesh Bagul. You can call me Tejesh, or you can call me Kai, and I'll come there. Or Mr. Bagul is also fine. Plus, yes, please go ahead.
Excuse me. Can you please share the screen?
Okay. Understood. I'm so sorry. I'll share my screen with all of you guys. Okay. All right. So I am sharing the screen. Just a minute. Okay. So I'm sharing the screen now. Can someone from the online folks please let me know that they have the visual? All good? All right, perfect. Okay, a little bit about me. We'll take one moment till the gentleman sets up the projector. All right. As I said, my name is Tejesh Bagul. You can call me Tejesh, Mr. Bagul, or just call me to your desk. I have a bachelor's in engineering, mechanical engineering degree from University of Pune, which is located in India. I also have a master's degree in mechanical engineer again from the University of Texas at Arlington in the US. I currently serve as the general manager for engineering and business development at Analema Group, where we are MEP consultants. That is our bread and butter. I have a close to decade and a half experience designing the MEP systems for various types of projects, be it hospitals, offices, schools, colleges, libraries. So that is where I excel as an engineer. I am a professional engineering licensee in the state of California. I am a chartered engineer from the Institution of Engineers in India. I have some certifications, the LEED AP BD plus C and the IGBC AP, which focus on green building technology. Along with that, I'm also a member of ASHRAE, ISHRAE, ASME, SAE, the Society of Engineers, as well as the Rotary Club. All right, so let's get to the heavy topic now. We will first take a look at what the course objectives are, what we will be discussing about, and how we can go about it, right? So first of all, we will have an introduction of the the systems of the projects that we will be working at. So we'll go through the basics of constructions. I know that everyone over here is well versed with the systems and the basics of construction. So I'll not go too deep into it, just a brush on the topic on what to expect, what to not. Then we'll take a look at the overview of the MEP systems that play a major role in the hospital projects day in, day out. Then we'll focus on why Revit MEP 2025, we are taking into consideration this software, this tool for understanding and designing the projects for hospitals. Next, we'll talk about what classifies a hospital. There is a lot of misnomer in the market. Is the neighborhood clinic also classified as a hospital? Is the OPD classified as a hospital? Right? So we'll try to take a look as per the standards that are set in the market that all of the consultants follow, majority of the consultants follow to understand what classifies as a hospital. In that, we'll take a look about the essential functions, the ICU units, so on and so forth. Next, we'll focus just on the MEP systems that are usually used in hospitals throughout the world. Next, we'll take a look at typical spaces, right? And hospital is just not regarding operating theaters. It's just not regarding, let's say, orthopedic areas. It's just not regarding recovery rooms. It's an assembly of spaces. There are different spaces that are for operations, that are for support, that are for administrative purpose. So we'll take a look at that, the common areas in the hospitals, what we can expect. Then we'll also take a look at how MEP systems, specific MEP systems are applicable to different types of areas in a given typical hospital project. Next, of course, we'll jump into the HVAC, the heating, ventilation, and air conditioning systems that are used for in hospitals. In that, we will talk about the importance of the thermal quality, the indoor environment quality, right? The air quality, the relative humidity, the temperature ranges that we need to maintain in a given space or given area in a given hospital. Along with that, we'll also try to correlate what we have studied till now into MEP, Revit MEP specifically, version 2025. Then we'll talk about the types of air systems that we classify different types of airs in a given hospital. The primary will be supply air, return air systems, the exhaust air systems, as well as the outside air systems. Then we'll talk about the wet systems. They are sometimes also called as water systems, but since we are using a lot of direct expansion, VRF technology, it's starting to be called as wet systems rather than just water system. That is why I mentioned this as wet system. In the wet systems, of course, we will talk about the chilled water systems for cooling the areas. We'll also talk about the heating hot water for making sure that the temperatures are maintained in the area, which is getting too cold, right? And in addition to that, we'll also be taking a look at the refrigerant flow systems. As I was saying, this is a technology that has picked up a lot. In hospitals, there are certain codes and standards that limit the use of VRF technology or DX technology, but still it is used in some parts of the world as the system for heating and cooling the air, the conditioned air in a given hospital. After that, heat load calculations, basically the bread and butter of an HVAC engineer in a given trade. We'll look into that with E20 spreadsheet. We'll make sure that we understand how do we set up thermal zones to make sure we get the maximum possible efficiency and utilization from the HVAC systems that we are designing. Along with that, we'll also take a look at the ventilation calculations and the calculations that are needed for supply air as per ASHRAE 170 standard. Next, we will take this data and then we'll start modeling what we need to model in Revit 2025. The same thing, the ventilation rates that I was talking about will be discussed. I will take a laser pointer. So this ASHRAE 170 standard entails with the ventilation requirements for hospitals. Then we will talk about the HVAC equipment that is used in the hospitals and how we can show these HVAC equipment in Revit, right? Everything having on paper written down is good, but of course it needs to be constructed. The contractors need to have a set of floor plans. They need to have a set of reflected ceiling plans that show our MEP equipment on there, right? And as many of you are mechanical engineers in the room as well as online, you might understand that HVAC systems tend to end up using a lot of space, be it in the mechanical rooms, be it in the ceiling space, so on and so forth. Next, we will make sure that we have proper integrations done, right? Because everything that we are working is collaborated. We cannot work in silos, saying like what happens on the electrical part of the project is not where I should be focusing on. It is basically a collaborative effort, and that is why we'll make sure that we have proper integrated system design for our systems. Next, we'll talk about the HVAC distribution systems, be it through the ducts or be it through the piping systems. We'll make sure that it is properly understood that how the distribution systems also play a major role in designing proper HVAC systems for hospitals. And along with that, of course, pressurization is a very key topic when it comes to HVAC in hospitals. So we'll make sure how we ensure that the airflows that we are showing on paper are properly addressed for the topic of pressurization, so that area which should not get less clean air gets the less clean air, right? Like in operating theater, you'd like to avoid as much as possible the less clean air, because the operating theater is supposed to be the prime most clean zone in a given particular project. Then we'll also take a look at the life safety, be it on the fire side, designing proper pressurization techniques, assigning proper fire smoke damper, fire dampers, smoke dampers, so on and so forth. In case of a worst case scenario of having a fire in the hospital, till the fire is contained, we need to make sure that the patients are properly mobilized to a safer section, and that is where these all technologies will come into picture for life safety. Next, of course, we will relay all of this information back into Revit, because that is what we are trying to do. Hands-on experience is what we're trying to do. So we'll make sure how do we properly relay this information, be it to the contractor, be it to the vendors, so on and so forth. Room designs is also one big thing. We'll make sure that the room designs is usually a task for the architect. But if the architect is not properly educated, that will create a lot of issues when we as MEP consultants and MEP designers are designing the systems. So we need to properly convey all of those thoughts to the architect so that proper room design is in place, and so that our systems can properly fit into the areas that we are planning to fit. Next, basically, air pressurization filtration will have a lot of discussion regarding different MERV ratings, HEPA filter ratings, so on and so forth as well. Commissioning, of course, commissioning is a topic that is handled by a different party. It's usually not the same consulting engineer who is designing a project that will do the commissioning. Commissioning, in general, we need to make sure it's someone else apart from us as consulting engineers for the project that takes care of it. Because that is kind of a peer review, you can say. That engineer, that commissioning agent will go onto the field, will verify the systems that we have designed and the contractor has built, are they working properly or not? If it is not, then we need to make sure that we take appropriate steps to counter any issues that might happen right away or in the future, right? But we'll still make sure that how we properly understand and how we properly relay this information with the help of controls diagram in Revit, so that proper sequence of operations for different HVAC systems are established. This is one thing that is still a work in process in the field of HVAC, the energy efficiency. Energy efficiency by its name means that we need to make sure that we optimize our systems properly. But while optimizing the systems properly, if you're trying to take energy from this area, you need to make sure that it is balanced in the other area. When it comes to hospitals, of course, hospitals, we are looking at life as a point of view, right? Life is utmost precious. If needed, this particular aspect of design gets overdrawn as compared to the other aspects. Life safety is the most important. We will still go through the energy efficiency measures that we can take for hospitals, but please make sure that your fundamental systems are properly designed so that long term there won't be any issues for the worst case scenario. All right, and then we will talk about plumbing systems in hospitals. The plumbing systems not just entail the sanitary systems or the water systems, the hot water or cold water. They will also look into the medical gas systems, right? So we will go over the medical gas systems as well. We'll take into consideration different standards, different codes, first of all, to design the water supply systems, right? The cold water, the hot water, those are the supply systems. On the other hand, the drainage systems like the sewer system, the venting system, so on and so forth. And then MedGas as well, we'll make sure that we go through it and understand what the requirements are as per different codes, right? Then we'll also take a look at the vacuum systems, which also comprise of the plumbing systems in a given hospital project. Next, we'll take a look at the typical plumbing equipment, right? There are different set of requirements that are needed in typical spaces in hospitals, where you need to have different set of plumbing fixtures or plumbing equipment, so on and so forth. And last but not the least, we'll take all of this information that we have gathered into Revit so that all of the information can be relayed properly on the paper, properly collaborated in Revit, so that when the contractor starts building all the system based on our design, they are not wasting a lot of time, right? So collaboration basically will be the name of the game for this course that we are doing. And then we will head over to the electrical systems. The E in the MEP stands for electrical. So we'll head over to the electrical systems in the hospitals, where we will be talking about different medical equipment, lighting that is required, life support systems that are required, how they need to be properly taken into consideration while designing your cables, conductors, conduits, switchgear, distribution board, panels, so on and so forth. We will also take a look at the emergency power systems. As some of you are from the hospitals, you might be well aware that power failure during a surgery means havoc, right? We cannot have power failure even for a second. But unfortunately, in some part of the world, it does happen. I'll show you an example in some time. Apart from that, we will also take a look at the lighting systems. We'll try to understand different measures of lighting a particular hospital. Along with that, we'll also take a look at the power distribution systems, namely in the single line diagram or one line diagram for electrical systems. And then, of course, we'll take a look at the selection of the power and lighting systems in hospitals. So with that, this was the course outline. I know it was pretty heavy. So please bear with me. We'll have much more, much more brainstorming on theory, because I need to make sure that you understand the basics, the foundation. If it is good, your building that you're building will be always properly secure. So we need to make sure we understand the basics and then we build on the advanced topics from. All right. Okay, let's have the introduction to the course and how we go step by step. First of all, we'll talk about the basics of construction. Again, this is not an in-depth thing because all of you are experienced in the room, so I'm not going to go into everything step by step. So first of all, let's talk about the timeline of the project. So as you see, the timeline of the project begins with the conceptual level design, when the owner of the hospital will basically put together some concepts on paper. They will approach the architects that they are trying to get the floor plans established. The architect will then understand their requirements, like there might be operating theaters that are needed. After the operating theaters, there might be recovery rooms that are needed, right? At the theater, when the instruments are done after the surgery, you might need to make sure that they are cleaned properly. So a sterile department might be needed, right? Along with that, administrative areas might be needed, like seating areas, waiting areas, right? Along with that, we'll make sure we understand different support areas that might be needed. There is a lot of cleaning of laundry that goes on in hospitals. For that, we might require steam. For that, we might require mechanical, so on and so forth, right? So conceptual level design is where the owner of the project will basically conceptualize, like, I want a hospital that will have these basic amenities, these basic spaces to begin with, right? After that, when it comes to the schematic level design, SD we call it, right? The schematic level design is basically where the architect will take a look at the plot or the area that they have gotten on field, and then they will start arranging those spaces as per the building code, as per the government norms, so on and so forth. Just because we have, let's say, 10,000 square foot of plot in our hand doesn't mean that the government is going to allow us to build the entire 10,000 square foot cut to cut. There might be some area that the government or the building codes will require you to leave for parking, some for emergency evacuation, so on and so forth, right? So that will be when the schematic level design will take into picture. Now, after the schematic level design, usually the consultants, MEP consultants like us, also get involved in the schematic level design, but the heavy work starts happening during the design development. It's called the DD phase. All right. Over here, the rough floor plan that the architect has created starts getting refined, right? As in, the spaces properly get accommodated on the floor plan. If they need to have extra corridors, that get accommodated. Any levels that need to be properly get accommodated on the floor plan, that starts getting done, right? So this is where the DD will take picture, the design development documents will take picture. After that, it comes to the construction documentation stage. This is where we'll start, as MEP consultants, we'll start to finalize our floor plan, all right? These floor plans will be as good as issued for construction, but only after the permit from the government authorities. There will be a building department in every municipality that we go into. They will have their own codes, they will have their own standards. Either they might follow the International Building Code or they might have their own standards to follow, right? So based on that, you need to make sure that our plans are properly coordinated so that it meets or exceeds that building code, right? That is where the construction documentation will take place. Now, before going to the next phase, that is the construction administration, as I mentioned, there will be a permit review phase, all right? As I said, the documents, the PDF, the plans, the floor plans, the entire set, PDF or printout, whatever it might be, the big ones, right? What is needed for construction. Once that is all finalized from our end, all of the equipment is specified, all of the HVAC ducts are shown, all of the switchgear is shown, all of the panel board schedules are shown, so on and so forth. Everything is done. It goes into the permit review phase. That is where the government authorities, it's usually called as the authority having jurisdiction, AHJ, will review the floor plan and approve it if the floor plans that we have designed fit the building codes. If not, they will give comments back to us. It will be our consulting engineer's responsibility to work on those comments and send it back for review again. It happens 2-3 times and then they approve it once the design matches or exceeds the building code. All right. Then this is where the building starts getting built, right? Till now, it was all on paper. This yellow thing was all on paper. Nothing was on the field. The field was just empty, barren lot, or there might be something that is going to be demolished and then there will be new building that is going up over there. All right. So this is where the construction actually starts happening. The plans that we have created, the PDF, the printout that we have created gets issued for construction, IFC, issued for construction. That is then used by the contractors to start building the building. All right. This is a very big process. Of course, the design might take maybe a year, but the construction, as we know, all are from construction industry, it takes years and years, right? So there might be some issue on the field that needs to get resolved, or there might be some RFI that will be coming in, some shop drawings that will be coming in, so on and so forth, and it just keeps on going and going. Now, this is basically where Revit comes into picture to reduce that amount as much as possible, right? At the end of the day, time means money. When we are delaying the process just because the contractor does not understand the floor plan, means that they are sending us the RFIs, they are sending us the documents or shop drawing reviews, so on and so forth. That is delaying the process. If they have that Revit model, which is already coordinated by us, right? We know that the ducts need to be so big, so the ceiling plenum needs to be so big with the hangers and everything attached to it. That time they understand that there is space for everything to be fit, and that duration of the construction in turn will reduce. That is the collaboration that we are talking about. In Revit, we are talking about specifically. We'll go into detail into that as well in some time. Now, once this construction administration ends, all right, before the keys are handed over to the client, before the ribbon cutting ceremony, it's all construction administration phase. All right. Once the ribbon is cut, the keys are handed over to the client, then it is the operation and maintenance that comes into picture, right? The building is in operation. There will be patients visiting the hospital. There will be doctors visiting, in-house doctors, so on and so forth. That is where the facilities team will take over and ensure that the work, that the design that the MEP consultants have designed, is it working well or not? All right. If there is some kind of complaint that comes from the resident doctors or visiting doctors, so on and so forth, the facilities team will make sure that they are on top of it and resolve that issue as soon as possible. For that, the facilities team might have their own team members who will actually work on it, or they might even outsource it to some other company to make sure it gets properly fixed, right? And again, as we are talking about, if it was an office building, it would have been fine that the AC is broken for a day or two. But when it comes to hospital, it becomes very critical that it gets resolved as soon as possible. So we'll also talk about resiliency and redundancy in the HVAC systems, electrical systems, plumbing systems. But to make sure you understand, all of the team members in this entire process take a lot of effort, take a lot of cognizance to the fact that the systems need to be designed properly. They need to operate properly as well. All right. Now let's talk about the color coding that I had over here, right? So first of all, the blue color coding. The color coding is basically to make you understand which party, which team member will be occupied in that particular phase of construction the most. All right. So over here, as you see, the yellow is basically for consultants. We MEP consultants are consultants, right? There will be a structural consultant, there will be a civil consultant, even architects are a consultant, right? Commissioning agent is also a consultant. So all of these consultants are heavily involved in the design when it is in the conceptual level design to construction documentation design, all right? Next, it is the contractors who come into picture during the construction administration phase, right? The cyan that I have noted over here, it's the construction administration phase, right? And next, last but not the least, it is the owners and their facilities management team that will come into picture when it is properly operated, right? But not to say that the owners are not involved during this phase. Well, the owners are the one paying for the project, so they are involved in every phase, all right? Be it for reducing the budget or be it for increasing the budget, the owners are always involved in it, right? Nowadays, with something called as an integrated project delivery, IPD, this is a very important term coming up in the field of construction, that your design needs to be already properly coordinated before it goes into construction. For that reason, the integrated project delivery means that even the contractor, even the commissioning agent, even the owners, even the facilities management team, if there is one in place, they get involved with the project as early on as possible during this process itself. So that will ensure that there is as limited time wastage when the building is being built or building is being operated. All right. Any questions till now? I know I've been talking a lot, but please make sure that you get heard, your questions gets answered. And if I'm going too fast, please let me know. That applies to the team on online as well. Emmanuel, any questions till now from online? Nothing? All right. Any questions in the room? Okay. All right. So if that is clear, let's move ahead with the next point that we have. We'll talk about some usual parties that are involved in a construction. All right. We have brushed on this topic in the timeline of the project, but we'll still understand this so that we understand when we are designing the hospitals, who all will be involved in that project, that we need to have proper communication. All right. First of all is the owner. The most important guy is the owner, because the owner will be paying for the project and operating the project as well, right? The owner will of course have their own project management team if they choose to, because the entire construction process takes a lot many teams to properly coordinate with each other. So usually the owner will hire a project management team that will coordinate with everyone, be it consultants, be it contractors, be it facilities management team, and make sure that the project is going on track. Next, consultants. Now, as I mentioned, even the architects are a form of consultants. We MEP consultants. Along with that, we will also have the civil consultants who will take care of grading, GIS information, so on and so forth. The structural team, the structural engineering consultant, will make sure that the skeleton of the building, be the beams, columns, slabs, foundations, are designed properly, because we need to ensure that the building lasts its life as much as possible. There might also be landscape consultants that might be on the team to make sure that different landscape features like lawns, exotic species of plants, any ponds that we have, any fountains that we have are properly accommodated. Even the parking lots are properly accommodated in the design. Commissioning agent, as I mentioned, commissioning agent will be a third party person who is directly hired by the owner in most of the cases, who will give like an impartial view, be it of the design or be it of the construction, to the owner. So playing basically the owner's advocate over here. And there might also be a specialty consultant, right? So now usually in the case of hospitals, there are specialty consultants. The specialty consultants will ensure that all of the equipment that need to be ordered, that need to be specified as per the area of the building that we are working on, are ordered or properly specified. They'll ensure that the cross team collaboration is also done. Many a times it happens that the electrical team is a different company, the mechanical team is a different company, the plumbing team is a different company, but the equipment needs to run with all the inputs, right? Like for, let's say, the pressure control panel that is used for HVAC systems in operating theaters. That is a combination of the HVAC consultant, HVAC contractor, the controls contractor, the controls consultant, if there is any on the team, that all gets consolidated with the specialty consultant. Some other specialty consultants, if I can give you some examples, might be food service consultant in restaurant projects, right? You have big restaurant projects. We need to order the equipment that will be required for cooking the food. Then there might be a seating area. So the food service consultant is like a specialty consultant. Just like that, you will also have a specialty consultant usually on a hospital project. Next, as I said, all of the consultants will put together the floor plans, the Revit model, the collaboration model, everything, but it needs to be built, right? That is where the contracting team will come into picture. As you might know, general contractors, they will take the floor plans from the architects, structural, civil engineers. They will build the building, basically the columns, the slabs, the beams, so on and so forth, right? The walls, the facade, the interior walls. So all of this is a part of general contractors. The general contractor in turn might also hire mechanical contractor. Usually the general contractor is the big contractor, and then they will outsource like the mechanical work to the mechanical contractor. Of course, mechanical in this case meaning HVAC. There will be also electrical contractors who will be installing, let's say, the lights, the life support systems, whatever requires a power and electrical power, right? That is where the electrical contractor will come into picture. The plumbing contractor will install the plumbing fixtures, water heaters, the valves that might be needed, any expansion tank, any accessories that might be needed. So all of this along with the med gas as well. So MedGas might have its own specialty contractor, just like we have a specialty consultant. But many a times the plumbing contractor will subcontract that work to a specialty contractor. And as I said, subcontractor is another one that you will come into contact with again and again. Like, let's say the HVAC contractor has subcontracted their ducting work, right? Or the plumbing contractor has subcontracted their piping work. Okay, good to go back online? Yes. Okay, all right. So I'll start sharing my screen again. To the folks that are online, sorry, we had a technical glitch over here. Hopefully now everything is settled. Okay, so Emmanuel, can you give me a confirmation the screen is visible online? Okay, perfect. And I'm audible as well, right? Okay, awesome. All right, so let's move ahead with our train. We need to make sure that we cover as much as possible, and it's already 4. I was expecting up till slide number 15, but we are on 12. But this is good discussion. I want to make sure that I explain as much as possible for everyone to understand. So, okay, let's talk a bit about MEP. I know everyone is experienced in the field of MEP, so I'm not going to go deep into it. First, the MEP, M stands for, of course, mechanical. That we are talking about in the sense of HVAC equipment that we will be specifying. Next thing is electrical. Electrical entails all the systems that require electrical power. Be it high voltage, let's say for the outlets that we have plugged over here, or be it low voltage, let's say for the controls that we have, right? So we have a high voltage and a low voltage. As you compare, different geographies might have different explanation for a high voltage, low voltage, extra low voltage as well. But we will try to keep ourselves restricted to high voltage, maybe 230 volts that comes out of the outlet. So it's 230 volts, right? In Rwanda, is it 230 volts voltage that you have? 230? Yeah, 230 voltage. So let's keep that as high voltage for the sake of our discussion right now. But when it comes to, let's say, the data outlet that we have, right? The LAN, that consumes somewhere around like 12 volts, 24 volts. So that becomes low voltage. That also entails with the electrical. On the other hand, the fire alarm devices also sometimes end up being 12 volt, 24. Okay. Again, sorry to the online participants. We had again some technical glitch, but I think so we have sorted it out now. And let me share my screen. Well, it's raining outside. Raining outside. So am I? That looks like my audio is on. No, you want me to log out and log back in? Good. All right. Okay, let's proceed again. Okay, we were on the topic of plumbing. Coming back to plumbing, be it cold water, hot water required from the faucets, from the taps at the lavatories or that we are talking about, be it in the patient room or be it outside of theaters where the doctors as well as the nurses are going to sanitize their hand and wash their hand. It's all taken care by the plumbing department or the plumbing contractor. All right, so let's talk about why do we require MEP systems in a given hospital, right? We have spoken a lot about the timeline, so on and so forth. But why exactly is this required? Let's discuss a bit about that as well. So first of all, it's to maintain the controlled environment, right? Right now, as we see, we are sitting in a room for the online participants to understand. We are sitting in a room which is open to outside, right? So this gives a lot of chance for the outside contaminants, if there are any, to come into the room and then affect the indoor environment quality, right? In the hospitals, this can be of fatal. The patient, if they have low immunity, might mean deadly effects for the patient if the environment in the hospital where they are treated or where they are resting or where they are operated, if it is not properly maintained, that might mean to fatal results. And of course, as I mentioned earlier, life takes the most importance when we are talking about hospitals, right? Next is for infection control, right? What happened during COVID? There was a lot of airborne particles moving around, affect many people. But this is in case of infection, right? So if someone has an infection, if that infection is transferred from one space to other space of the same hospital, or from outside to inside, if the air is not properly conditioned and filtered, that will take into consideration the safety hazard and again leading to catastrophic failures that might be in place. The infections might be in the case of biological, right? There might be some droplets coming out of someone's body that might be transmitted to someone else, and that might create an infection in the other person as well. Next, chemical. There are a lot of chemical fumes also in the hospital that they maintain at a given space. If that gets translated to some other space, that might also mean a lot of issues. Radiation, X-rays, MRIs, these need to be properly maintained in the given environment. So that is not unnecessary, not supposed to be affected with that radiation. Say you go screen and behind a wall and stand. That is because they are exposed to that radiations again and again. Unlike us, who will be exposed just for the sake of that time duration when we are taking the X-ray, right? So making sure that the spaces are controlled for the radiation. Now let's talk about the mode of action of bacteria or of these biological issues that come into picture. Biggest area the needle bodily contact that's possible, and that is where the infection control comes into picture when we are talking about MEP systems for a given hospital. Then we have the airborne transmission. It was a classic example when we were talking about COVID-19. So it was airborne. It was very hard to contain it. All of the hospitals were full because it was airborne and we couldn't trace it. Be it coughing, or be it amplification of those the bacteria in the HVAC systems itself. So just a show of hands, how many of you have worked with cooling towers before? A water-cooled cooling tower. Anyone has worked on those before? No, it's used in conjunction with the chillers. Chillers, you'll have chiller and then you will have a cooling tower. It's called a water-cooled chiller. So if a water-cooled chiller, you will have a cooling tower outside, which will basically bring down the temperature of water that requires to be brought to the condenser of the chiller for heat rejection. Now that cooling tower, if you go on an average building, has a lot of Legionella. Legionella is basically contributing to many life hazards throughout the place. And when we are talking about hospitals, be assured that when you have a cooling tower, you need to make sure your HVAC systems, your MEP systems are properly coordinated, because we don't want Lisa to back to environment of the hospital. It affects areas as well. So basically, that is the basis of why we are trying to use MEP systems in a given hospital. Any questions till now, gentlemen? Yes, all professional engineers, you might have good stories of yours as well. So please make sure you make those stories and make that feedback heard as well. Okay, so let's do the next one. So basically, the controlled environment that we are talking special control, right? The biggest one over here turns out to be the maintaining the or maintaining the temperature and relative humidity. Okay, so now that outside, the relative humidity of the area increases, becomes humid, right? That's what we call in language. The average relative humidity, so in Kigali, is somewhere around like 60 to 70%. It's usually called in percent, right? Again, as we talk about humidity, we talk about new water that are capable of bringing the fan from one area to other. So when you have a patient who is trying to recover, we want to make sure that all those relative humidity is properly maintained, be it in the operating theater, be it in the recovery area, so on and so forth. That is where relative humidity comes into picture. Again, if you go to a hospital, you find a patient over there, most probably they are using the apron that they are given by the hospital, right? They are right. So one piece they not bagging about a scantily dressed patient, right? Right now, well dressed, we have zone sweaters, jacket. Who is trying to recover from a disease or from some kind of illness, their heat rejection will be amplified from their body, because if your temperatures in your rooms are too low, and then if it is too high, then it will cause too much sweating in that case, right? So for that reason, we need to make sure that the environmental control of different medical functions are properly set. We'll take a look into ASHRAE 170 standard, which specifically gives us the temperature range, the relative humidity range. It will also give us the air change rates per hour. It is sometimes called ACH, sometimes called as ACPH as well. Air change per hour or air change per hour. ACPH or ACH, all right? Next, the patient usually is exposed to the environment on a continuous basis. Now let's talk about a typical day in a given hospital, right? The patient who is admitted in the hospital, if they are on a long-term basis, they will be in the hospital or in the premises of the hospital for an extended period of time, right? But the doctors might be coming back and forth and going home, coming back. Their family members might be coming to the hospital, going back. But the patient is in the hospital for a prolonged time. So that makes it even more critical for us to design our HVAC systems properly so that the patient is at the utmost comfort level as possible to make sure we have adequate environment quality for them to recover as soon as possible. All right. Now, let's. The third point is basically the same thing that I was talking about. Like if the patient is scantily clad, scantily dressed, the ability of their body to regulate their temperature, because they're in, is not proper at that point of time. Because most of their bodily systems, most of their white blood cells or whatever it is, I don't know the exact specific term, are focused on making sure that they get recovered. And if our HVAC systems that we are designing gets focused on their systems to maintain their core body temperature, the illness will get prolonged, right? So for that reason, we need to make sure that the HVAC systems deliver air that is properly assessed properly as per the standards of ASHRAE or FGI standard. We'll also talk about so on and so forth. But on the other hand, when we talk about healthcare workers, they sometimes have to wear that PPE, right? That PPE word, the professional, what is it called? Protective professional equipment. All the big thing that the nurses and doctors were wearing during COVID time to make sure that they don't get infected, that is very insulated from all of the exterior atmosphere, right? So making sure that our HVAC systems also properly analyze that, because it's just not the patients. Of course, the patients are a priority, but it also the staff that will be treating the patient that need to be taken care of, right? Next is the noise control. Think about the construction site right next to a hospital area where we have recovery rooms. The more the hammers in that operating area are going on, the less pleasant it becomes for the patient to recover. Life safety, of course, as I mentioned, since we are trying to save lives over here with properly addressing the illness or the procedures of the patients, life safety on the part of, let's say, fire becomes also a critical thing. That is also why we need MEP systems in hospitals. One more thing is regarding natural calamities. This usually comes into picture if the hospital is in the area, let's say, that can get flooded due to natural calamities, that can get that are in the earthquake-prone zones. Then these considerations also come into picture, making sure that the patient, the staff will be as secured, as safe as possible. Okay, so one more thing regarding MEP systems or let's say general MEP systems and the systems that we have designed by the architect or the structural engineers. When the architect designs their columns or the facade, the windows, the structural engineer designs their columns, beams, slabs, so on and so forth. These are like one-time first initial capex, you can say, right? One time you build it, it is there. But the systems that we design are going to run throughout the life of that building. It is also called as services, right? The MEP systems are also called as services. That entails the HVAC systems, the electrical systems, the plumbing systems, fire protection, fire alarm systems, data and telecom as well. As I mentioned, data is something that you get LAN power out of. Telecommunication is for your phone, the nurse call, we call it. That is all telecommunication. Now, next, talking about the efficient indoor environment quality. There is a difference between IEQ and IAQ. IEQ stands for indoor environment quality. Okay. On the other hand, IAQ stands for indoor air quality. All right. There is a bit difference between both of those. Indoor air quality is a subset of indoor environment quality. Right. In that, you will also have the lighting systems will be taking into consideration. The best lighting system I would recommend would be the natural light that comes from the outside into the rooms. But times like this, when we have a darker outside condition, we need to have artificial lightings like we have right now that are properly suited for the indoor environment quality, right? That is also where the MEP systems will take a weightage to how the HVAC systems, electrical systems, plumbing systems run properly in a given hospital. And of course, there are different areas that we need to properly collaborate between, like the dialysis machine areas, the X-ray areas, the heart rate monitors. All of this will basically come under the electrical systems that will take into consideration. And the last three that we are talking about over here are mainly focused on the plumbing systems. The sterilization will be focused on the steam systems. The med-gas, of course, whenever we have surgery going on, there will be different gases like nitrous oxide, nitrogen, oxygen, carbon dioxide that will be required for facilitating that surgery. And that is where the med-gas will come into picture, and so will the compressed gas as well. All right, before going into the next point, looks like it is almost an hour. So Emmanuel and Gorky, so it's almost an hour. Do you guys think we can take a bio break right now so that you can take a restroom break or something? What do you guys think? Do you want to go on or do you want to take 5-10 minutes break? Sorry? Continue? Okay, all right. Let's continue then. So now this was the introduction towards hospitals. Now let's talk about the tool that we will be using, right? So the tool that we are using currently is Revit, right? But let's talk in a bit detail about Revit as well and how it comes into picture during the construction design, right? So first of all, let me clear one thing over here. Revit and BIM are interchangeably used many a times. But please understand, Revit is not BIM and BIM is not Revit. Okay? There are two different things. Revit is a part of BIM, but it is not the entire BIM thing. It is just a part of BIM. It is a tool in the big set of BIM. All right? BIM stands for Building Information Modeling. Revit is a tool that is used for enabling better coordination between the trades. All right. And specifically talking about BIM, BIM is a process. It is a process where we try to build as data-rich models for proper collaboration between different trades as possible. All right. It is a process. Okay. So this process, what we are trying to do is we are trying to accomplish two things. First of all, we are trying to build an intelligent model. So many of you folks might be also working in even motor, right? You cannot in say regarding warranty, so on. So here we are trying to accomplish is trying to make a intelligent model that can facilitate time efficient as much, right? Now, as I mentioned, just not for MEP consultants. Revit is just not for the consultants, just like that, the architects will use it. Even the civil engineers, structural levels. All right. There might be tool that they might be using, let's say Revisto that they might be using. Okay, so I'm back online. Matt, can you give me a thumbs up? All right, perfect. Okay, so moving, it's just not trying to show something on the paper with BIM. And again, this BIM process is heavily used nowadays. Throughout the world, you have BIM being implemented in projects, be it a small scale 2000 square foot or be it square foot. This particular this looks like the rains have spoiled the show a bit over here. Okay, just a minute, team that is online. Okay, Emmanuel, all good? All good? Okay. All right. So as I mentioned, Revit is a tool. Yesterday it was AutoCAD, today Revit, tomorrow it might be something else. All right. But it is very important for us to really go through the steps and understand how we can use Revit to facilitate as much time and cost saving for us as possible. Because in the field of construction, time and cost are two things that will cost on a bigger picture, even if there is a small delay in the project. Right? Okay. Let's move ahead. Okay, so let's talk about why do we think about Revit in a hospital? Excuse me. So let's take a look at some typical construction sites. Since you guys are already working in the field, this might not be something new to you. As you might see, it is heavily crowded over here, right? We have the ducts going in the center over here. We have the metal studs over here. We have some more equipment that is already on the floor to be installed. Another typical site, you have the pipes going in, you have the beams over here, you have some more metal studs, you have some chipboard, right? Again, very typical. And over here, it is more of like a completed aspect of a construction project where you have insulated ducts, you have electrical systems over here, some conduits over here. So you see everything needs to be coordinated, right? But if this coordination is not done, what happens then? So let's take a look about that as well. And this is one of my favorite couple of slides in the entire presentation, I would say. So let's take a look at some typical construction sites. Have you guys come across this issue before? So, all right. So we are on the same page now, right? So let's take a look at another one, right? How about another one? So, okay, team, what do you guys think? Is this something that an inexperienced staff might do on the field? Yes? Something like that? Now, let's go on to the next slide and see what is going on there. So, this is a floor plan, gentlemen. Okay? This is a call out, as you might know, right? It's calling out for this detail number 2 on the sheet A6.10. And it is trying to call out some detail over here, right? If you properly see over here, what the contractor has ended up doing is, the contractor has made another step over here, thinking that this is a step. Well, wait for the best part of it. You see something round over here? They have even made grooves to make sure that they show this round and 2 and A6.10. All right? Now one more for you. Have you seen something like this on your floor plans before? It's called a revision cloud. This is a revision cloud. And by the way, this is from internet. This is not one of my projects. So this is a revision cloud which did not have the delta tag. Usually there is a delta tag associated with the revision cloud, right? So the poor consultant did not assign the delta tag, and apparently the contractor just ended up drilling hole and making a hole in the floor over there. So gentlemen, just let's brainstorm over here. If we were saying that this is some experienced staff who might or might not have a floor plan in hand, or they are just doing a design build kind of project, this should have been something from an experienced staff, right? But still problems like this do happen on the field. And if we are seeing graphics like this over here, it means these two particular instances happened after the inception of AutoCAD, right? Because the text seems to be something typed out, because long back ago, 1970s, 1960s, the architects used to hand draw it, right? So that graphic and this graphic is much different. This is something computer made, right? But still these issues are happening in the field, right? Now, okay, this might be to some extent correctable, but what about this issue? This is a grave mistake, right? It might even mean demolishing a big chunk of that slab altogether, right? So this is exactly where collaboration comes into picture, where Revit comes into picture. All right. Okay, let's so there are many facets of BIM. Okay, but for our consideration, I'm going to take 3 of them, a 3-pronged approach, if I may. And out of those 3, one is the one, the first one is that we in this course will be collaborating, because that is related to the design aspect, the MEP consulting, MEP design aspect. Okay. That one is the coordination aspect. Okay. So coordination, be it between the trades, like another team member is working on the electrical team and I am working on the mechanical team and someone is working on the civil team. Everyone between the trade can collaborate using BIM, using the power of BIM. The next one is in-house collaboration. Many times it happens that MEP consultants are all sitting in the same office under the same umbrella of a company. But the structural engineer might be somewhere else. The civil engineer might be somewhere else, some other company, right? So in-house as well, there might be different coordination that might be going on. Like if sir over here is working, let's say on first level, I might be working on second level. But the ducts from both of these levels need to be connected to a common duct that might be in the shaft, right? So that is the in-house coordination that can happen, right? Next thing is the biggest asset of BIM as per me. Okay. You might be sitting in Kigali, you might be sitting in Lagos, but you might be coordinating a project in Australia. Why? Because you have the power of BIM to assist you to coordinate between overseas team as well. Like I usually I'm originally from India, all right, but I have projects going on in the US, I have projects going on in the Middle East, I have projects going on in India, and soon maybe Africa as well, right? But that's the thing, that's the beauty of BIM. You don't need to restrict yourself just to one geography, and this all happens in real time. If right now it is, let's say, around 4:30, exactly 4, and let's say it's in the state of California, let's say it's early morning for them at 8 a.m. or something, that engineer and you can be working at the same time in the same model, in the same Revit model at the same time, and then you can be collaborating with each other so that you don't need to go back and forth via emails to understand what needs to be done and what doesn't need to be done, right? So for countries like us, like Rwanda, Nigeria, India, we have a huge potential that is left unexplored because we have not jumped deep into BIM, right? Okay, going next, this was the first prong, by the way. The coordination is the first prong that I'm talking about, the first facet of BIM that are important from this course point of view. The second, we are talking about data management. Okay, so data management can entail the equipment scheduling, right? If you're ordering, let's say, an exhaust fan, right? For garages, it's a jet exhaust fan, and you have hundreds of jet exhaust fan because your building is a big one and you have underground parking. Revit, specifically Revit, will help you properly put that information together in the equipment schedule, schedule, whatever you call it. All right. Under that, let's say you have a big air handler and you have different parts. It's a custom air handler. You have ordered the fins from a vendor. You've ordered a fan from another vendor. You've ordered let's say airflow monitoring station from another vendor. So properly scheduling those parts can also happen in Revit itself. You do not need to go into another app or another application like Excel or AutoCAD to make it happen. It can happen in Revit only. Next are the shop drawings. Has anyone, by the way, heard about LOD, level of design, in the past? No? Okay. So what ends up happening, consultants, there are different level of design. LOD, that's an abbreviation of level of design. So it begins with LOD 100, then it goes to LOD 200, 300, 400, 500. So these are granularity of your Revit model that happens. Okay. We spoke about the different phases, right? We spoke about SD phase, we spoke about DD phase, we spoke about CD phase, construction administration phase earlier, right? So think of this as tying up into that. When you're talking about schematic level design, the level will be LOD 100. When you go into design development, you'll progress into LOD 200. Basically, if you have a bigger duct and you're fine-tuning that duct, that will come into picture. If you have an insulation wrapped around the duct, that will come into DD phase, basically LOD 200. Now 300 is basically for the construction documentation. That is where you take into consideration, let's say, how much space is required for the hangers to hang, let's say, a cable tray or maybe conduits, right? If sleeves need to be made in beams, all right, that is coordinated with the structural engineer, and then there is proper allocation of that sleeve in that beam taken into consideration. As you go on to level 400, that is where what actually will be constructed on the field takes into consideration. Your hangers, your clips, your accessories, everything will get into Revit model at that time. That is when you'll have LOD 400. Okay. LOD 500 we are talking about for as-built conditions. Do you guys know about as-builts? Right? So whatever is built over there shows up in the Revit model. That is the LOD 500 level design that is meant for as-builts. Okay. So again, that also comes under the data management, because that entails a lot of data that we are trying to coordinate through different team members. Now, RFI's request for further investigation or request for information is something that us as consultants will keep on getting from the contractors on the field, because even though we try to coordinate as much as possible in AutoCAD, there might be some blind spots that we might not be able to see. So that is where they will come into picture. Or maybe there might be some accessory, some fitting that we see is available in Revit, but it might not be available in the market, right? They might need to import it from some other country, which might be very expensive, given not that criticality of that part, right? In that case, the RFI will come asking Mr. MEP consultant, can we change this to this alternate? So based on our experience, based on the calculations that we have done, we might approve it or deny it, right? Next, talking about estimation. So estimation comes into picture when we are talking about contractors, right? Contractors will be the one who will be doing the heavy work for the financial side as well. They are trying to make sure that they not only meet and exceed the design of the consultants, but also try to make money in the sense, right? Because everyone is in the game to make money, to make a living as well. Next is the costing and pricing. This kind of goes hand in hand with the estimation, right? If you design the duct system, you get the sheet metal, how much square foot sheet metal or square meter sheet metal you need, multiply that with the unit price, add that to the labor costing. That is how you will get the costing and pricing for your project, right? Okay, what time is it? 4:30. Okay, so as I mentioned, the first aspect was the coordination aspect. The second aspect is the data management aspect. All right. Now we'll go to the third aspect for why BIM in hospitals is for the operation and maintenance. Okay. As I mentioned, BIM is there to stay with your project right from the conceptual level design all the way up to the end of life of the project. All right. You can try to utilize it as much as possible to make sure your project is as successful as possible. So when it comes to operation and management, you can take that information from Revit model specifically and create a digital twin. All right. What is a digital twin? Has anyone worked with building automation systems here? Building management systems, right? So when you have your digital twin, you can take your digital twin and you can work with your building automation systems provided to feed that data into your building automation system, right? What that will do is that will take your building automation system data all the way back to when it was conceptualized. The MEP consultant, if that engineer is creating some system and they are assigning that data to that system, right? Let's say my duct was designed for 0.08 inches per 100 foot water gauge, right? All right. That's usually what many of the duct systems are designed. If that data is embedded into the digital twin, it will take care of it in the DS as well. All right. That can help us understand why the part failures are happening. Let's say you have an exhaust fan. It is, let's say, a direct drive exhaust fan. Couplings are failing again and again on there. The reason might be the overload on that exhaust fan, right? But it was mentioned by the consultant that there needs to be a variable frequency drive. Just as an example, there needs to be a variable frequency drive. But what ends up happening is variable frequency drive does not get ordered. The fan is working at 100% capacity all the time, which is leading to the coupling failure again and again. That data also can be taken into consideration for operation. Next, talking about predictive and preventive maintenance. When earlier in the talk I had mentioned, when we have a project going on, specifically a hospital project, a few seconds of failure in the equipment might mean consequences at the end, right? For that, if you predict the failure beforehand, you can do proactive maintenance on that system. Let's say a belt is failing again and again. You understand the frequency of the failure. That can be taken into consideration with them as well. Next is the energy efficiency performance. As I mentioned, we will talk about the energy component when we are doing the heat load calculations as well, right? So when we do heat load calculations, we have Q equals to mCp delta T. Very common equation in the field of mechanical engineering, right? There is temperature T1 in the outside, T2 in the inside. We have a delta T, and then we are trying to maintain the heat loads based on that particular calculation. Q equals to mCp delta T. That is very common calculation in the field of mechanical engineering. Now, what we have designed our systems for and how it is actually behaving on the field, that we can compare it with the previous record, what the design engineer had done in the conceptual level design. That is also where BIM will come into picture. So as I mentioned, the first one, coordination, second one, data management, and the third one, O&M or operation and maintenance management is what we will be talking. But out of these three prongs, as I mentioned, coordination is the biggest aspect that we'll need to take into consideration for this course. All right. So this course's focus will be coordination. Having a good coordinated model sent over to the other teams, be it the contractors, be it the consultants, that will reap benefits in the longer term when it starts getting built. All right. And since we all are experienced engineer in this room, what it will help us is to apply our learnings, challenges or mistakes that we have made. We all make mistakes, right? We are human beings. We all make mistakes. But the way we tackle those challenges, those mistakes is what we can apply with the coordination aspect, right? So it is 4:45. Let's take a 10 minutes break. I think so. I also need to go to the washroom and come back. Emmanuel, 10 minutes break. All right. Sorry? No, that is at 6, right? 6 p.m. So right now it is, we can take a bio break for 10 minutes, right? 5 minutes? All right, let's make it 5 minutes. Okay, so I'll announce it. So to all the online participants, we are taking a bio break for 5 minutes. So we will resume back after 5 minutes. Thanks. Oh, it's getting hot in here. So, Emmanuel, keep your mobile on there.
So, hello for those who are online. We are having the time for break, 5 minutes to resume the training.
Okay, all right. Let's get started. For the online participants, this is so we spoken about some for the. Okay, I need to from the. Now we will start focusing on what exactly classifies as a hospital. All right, because as I mentioned earlier, there is a lot of lingo that goes around in the market regarding hospitals, but for the sake of standardization, right? So just like we have ASME codes for pressure vessels, right? So that is basically the standardization of the codes for pressure vessels. Just like that, there are different standards followed in the field of construction as well, right? So we'll take that into consideration to define what constitutes a hospital actually. For that, we will take a look at the International Building Code. Okay, there are different codes related to the field of construction in the market. It is our responsibility as consultants to properly understand which code is used in which jurisdiction, right? Maybe the building code that is used in Rwanda might differ from the building code that is used in, let's say, Tanzania. That also might differ with the building code that is used, let's say, in Kenya, right? So it is our responsibility to do the research as MEP consultants and designing engineers on which building codes to use. Now, talking about this particular building code, this building code, see your phone, right? Okay. So this building code focuses on aspects regarding architects. Okay, the building code usually focuses on the aspects regarding architect. There will be a different mechanical code, international mechanical code, that will focus on HVAC systems. There might be a different international electric code that will focus on the electrical system. There might also be plumbing code. There might be energy efficiency codes. All right. So all of these codes need to be taken into consideration when we are designing our projects. All right. So again, make sure that you understand, make sure you do the research which building code is applicable to the part of the world where your building is being constructed. If you refer to the incorrect code, the authority having jurisdiction will kick back your proposal saying that nothing. All right. For the sake of standardization, we'll go ahead with the International Building Code, which is usually the most followed code throughout the world. It is kind of adapted to different countries, but it is most probably used. First of all, the International Building will define different type of buildings based on the use that they have. Okay, so you'll come across something called as an ambulatory care facility. This facility will provide medical, surgical, psychiatric, nursing, or similar care for less than 24 hours. Okay. So if a person is visiting that facility for less than 24 hours for an illness that is rendered incapable of self-preservation, so that patient cannot do self-preservation, that patient, he or she goes to the hospital, gets themselves treated, and then relieves the hospital within 24 hours is what is ambulatory care facility. To give you an example, let's say someone has fainted. All right. They have not gained conscious for 5 minutes. The people take them to the hospital. It was only analyzed that they had dehydration in their body. So the hospital doctor will recommend IV treatment for them. Once they are gone through the dosage of IV treatment, they are fit and fine, they walk out of the hospital. In the self-preservation case, that will be a ambulatory care facility. All right. Next, we are talking about the care suite. Now, every building that you will work on will be classified as per the occupancy that it goes through. Okay. There is different section in the International Building Code that will give us a group of occupancy for different types of spaces. Like this space that we are sitting in is a conference area. This will be a different occupancy as compared to, let's say, the open air restaurant that is on the top floor over here. Just like that, excuse me, the hospitals under the International Building Code, which are specifically for care suite, are classified under group I2. I in this case stands for institutional. Okay, there are many group occupancy. I would recommend for everyone to try it out on internet. The codes are available freely. I will just let you know how to find that. Okay. So if you simply go to the building code, it will give you, it will give you the option for codes. The International Code Council, iccsave.org, is the website for the International Building Codes. So if you go to this building code, as well as we'll talk about the different buildings that we have option for. Someone from the online can please confirm that they can see my Google Chrome screen. Perfect. All right. So this is the website for the International Building Code. As I mentioned, there are different types of building codes that will be in picture. In this case, we are looking at the building code. These are read-only versions. You won't be able to print it. I would recommend still. All good, right? Okay. So looks like it's taking a bit of time, but I want to make sure that I walk you through all the codes that are available. So maybe after the long break that we have planned, I will walk you everyone through the different types of building codes. There is a plumbing code, mechanical code, electrical code, so on and so forth. So we'll move back to our presentation. So over here, just like we were mentioning regarding the care facilities, in the care suite that we are talking about the treatment rooms where after the treatment is done and patient is trying to recover, that is where they will be accommodated, right? This particular care suite will be under the supervision of the staff that is there, right? Something similar to the ICU, intensive care unit, right? In an ICU, you have a team of nurses and doctors who constantly monitor the patient. On the other hand, if you have just a recovery room, there will be one nurse maybe between 10 patients, right? And when the patient rings the nurse call button, only then the particular nurse will go and attend that patient. Okay, talking about the next one is the clinic and outpatient. All right. So now again, we are talking about less than 24 hours in this case as well. Okay. But over here, we are talking about an illness that is not rendered incapable or self-preservation. Let's say you have a cold, right? Cold and cough. So you go to the outpatient department and you get yourself treated. But you know yourself that you can drive, you can properly function, and that is where you will classify this particular aspect as. Or let's say someone has undergone an angioplasty, right? That's something related to the heart, the cardiac department, right? And they want to go and have their checkup. They are done with the procedure. They go to the outpatient department just to make sure that they have a regular check. They order their pharmacy tablets and come back. So that is where the clinic outpatient will be defined as. Next, we are talking about medical care. Okay, now this is a big term. Medical care typically entails a big term, since you can see it is a care involving the medical or surgical procedure. Be it a cough and cold, or be it a major heart surgery, a bypass surgery that you'll be doing, that will be on the nursing and psychiatric considerations. And last but not the least, we are talking about the hospitals and psychiatric hospitals. In this case, again, we are talking about a longer duration of a person staying, that the patient might be in the facility for 1 day or more than 30 days as well, right? Let's take an example of a burn victim. Till the burn victim is not properly healed, they don't allow the burn victim to go out of the hospital, right? So that is where we will classify the hospital as. All right, now that we have taken a look at different types of definitions for the hospitals, we will take a look at we will take a look at some of the different care facilities in a given hospital. Okay, as I was saying, the acute care hospital will be basically something where a patient will go between the length of 1 day to 30 days to get themselves cured properly. All right. Next, we have the health hospital. They will be focused on the psychiatric care, right? There might not be a lot of surgical areas, recovery areas as such. More focus on patient treatment areas like that, right? Next, we are talking about the primary outpatient clinic, right? So again, here we are talking about that where the patient will be admitted. Let's say if that patient is in a accident, a road accident, where they will go first point into the hospital, that will be classified as the primary care outpatient center. Let's talk about the next one is the primary outpatient facility. This is a neighborhood clinic that you might go for cough and cold. If you don't have a big hospital which has an outpatient department that can heal you for cough and cold, this is where you will go. Okay, they usually are smaller in the area as well. They're not that big. They're very small in the area. They might maybe have 2 or 3 doctors. That might be an MD, masters in not MD, masters in medicine, and they will treat the patient accordingly, right? Next, we are talking about the outpatient surgical facilities. Now, this facility is somewhere that the patient is directly getting admitted, and without going to the pre-operative room, they are directly taken into the surgical unit, right? Specifically talking about the operating theaters. If someone has gone through a trauma like an accident, they will first come to the outpatient center, and from the outpatient center, they will be transferred for the surgery. That is where the outpatient surgical facilities will come into picture. Let's talk about the next type of hospital. This is kind of a hospital, but not exactly. But since there are full-time doctors available in assisted living facility, basically somewhere where the senior citizens live after they are done with their retirements and whatnot, and they need to have constant care being taken for themselves, is where the assisted living facility will come into picture. Okay, this assisted living facility is kind of an apartment system you can consider. Okay, there might be like a studio apartment for each of the senior citizen, and they might or might not have a kitchenette. What is a kitchenette? Is a small kitchen countertop area that they can cook, or someone can come over there and cook. usually what ends up happening is that they will have a big kitchen area, and that is where their cooking will be taken into consideration. Next, now we are coming into something deeper into the picture, which we are talking about the patient care units. Okay, so the patient care units, we are talking about the general, medical, and the surgical nursing units. Now these units, this is kind of a blanket term. You can also use it for medical, surgical, orthopedic, psychiatric, pediatric, gynecologist. So all of this is a blanket term for the general medical and surgical unit spaces. And many a times what happens is these spaces tend to not being a critical space, right? Like it is not life-threatening to the patient right away. This is where they will be treated. Now, talking about the airborne infectious isolation rooms. For the folks who have been to a hospital, when the patient is recovering in a recovery room, before going into the room, there will be a small anti-room, they call it, or an isolation room. That is where you need to make sure that you enter through so that you limit the contaminants going into the particular recovery room. All right. So that is where the isolation will come into picture. Next, talking about the protecting environment rooms. These rooms are usually constantly monitored. This was something happening during the COVID times where we needed to have constant monitoring of the rooms going on into picture, making sure that the contaminants level don't spike up, and that spike giving rise to even more COVID patients, right? So as I mentioned over here, there are 6 surfaces, right? 4 walls, 1 floor, and 1 ceiling. All of the six surfaces are to be maintained at positive pressure. What is a positive pressure? The air that you are bringing into the room, right? Everyone knows the unit for volumetric flow rate, CFM. Have you guys heard about CFM? Liters per second, right? So that is all volumetric flow rate. So volumetric flow rate needs to be positive. The CFM needs to be positive. The pressure needs to be positive. What is that? If you are bringing 100 CFM into a room, you are only allowed to have less CFM in the return air duct going back to the air handler. Basically trying to maintain positive pressure. So the air will seep out through the cracks, through the infiltration, but it will not come in. Why will it not come in? We don't want the outside contaminants coming into the room. All right. That is why we need a positive pressurization. But on the other hand, if you are talking about a toilet, okay, in the toilet, we don't want the toilet air coming outside the toilet, right? We want it other air to go into the toilet because toilet is considered as an unclean area. So we need a negative pressure in the toilets. We'll talk about the pressurization in some time as well. Critical care nurse, this is something related to extremely ill patients who are directly admitted into the ICUs, into the CCUs, the cardiac care units. That is where you'll classify the critical care nursing units. Next, talking about the newborn nurseries. Once a child is born, they need to be isolated for some time, making sure that their immunity properly matches to the outside world. That is where the newborn nurseries will come into picture. Now, the newborn nurseries are also classified into 3 types. Okay, many a times what happens is the newborn is not adapted well enough to the environment, to the outside world. That is when, if they get critically ill, they transfer them to a level 3 newborn nursery. All right. If it is noticed that the immunity of the infant is compromised, but it might develop in the later stage, that is when they need intermediate care, and that is where you will go into level 2 newborn nursery. And level 1 newborn nursery is for the infants who are born just fine. They are not given any critical issues assigned to them. Labor, birthing, and recovery units. Newborn mothers, new mothers who have newborns will have their delivery done, labor done in one area, and then they will be shifted to a recovery unit, or maybe the same space will act as their recovery unit. It is also called as L&D unit when it comes to the abbreviations used in hospitals. Okay, there are some more areas I want you guys to stick with me. I know there is a lot of theory talking over here, but please understand we are going to use this theory to relay that information into Revit to numericals. So please bear with me. I know it's a lot of theory. It's evening time. We have done our lunch. It is too drowsy, but please bear with me. Okay. Some more patient care units we'll talk about. The bone marrow transplant. It's a common reoccurrence happening in these days that patients need to have a bone marrow transplant. That is when this particular unit will come into picture. Next is a physical therapy, also called as physiotherapy sometimes. This is regarding the illness and the rehabilitation that is required to restore the muscles, the musculoskeletal function that we are talking about over here. Subacute care units, we are talking about subacute conditions that are not very acute, that it might be fatal for that person to be admitted over here, right? Okay, and we'll talk about now the surgery suites. We are also talking basically about the operating theaters, operating rooms. It is also called OR, OT, surgical suites, so on and so forth. As I mentioned, outpatient surgery suites are something where the outpatient who is brought under emergency purposes come into the emergency room, emergency operating suite to get operated right away then and there. There cannot be any time delay happening to make sure that the surgery happens on that patient as soon as possible. Next, talking about the inpatient. So many a times what happens is the surgery is planned. Okay, you have a patient coming into the hospital. They have been diagnosed with some kind of illness or disease. The doctor will recommend some landing period for them, maybe 1 day or 2 days of hospitalization so that they can track their vital signs. After that, they are taken for surgery. After that surgery is done, they are moved into post-operation or post-op rooms where they stay for the time of recovery till the doctor allows them to be discharged. So that is what a inpatient surgery suite will be about, right? Okay, along with this, of course, we are heavily talking about all the patient areas where they get recovery, where they get operated, what happens in the case of emergencies. But along with this, we also need administrative areas, right? Such as general offices. You might have a doctor's office where they don't treat anyone. They just have a one-on-one conversation with the patient, so on and so forth. There will be accounting area, right? Business offices, patient records, right? Nowadays, these patient records are becoming more on something called as a patient information system, where you have a data center and you have all the records online. But when the doctor writes it, it first gets into the patient records and scanned and then transferred into the information system. We have the main lobby, the admitting, the waiting areas. When you go to an hospital, they don't directly take you in there. They make you wait for some time, paperwork, and then go inside, unless and until you're in a fetal position. Outpatient services, that is also one of the administrative areas. Education department for continuous learning of doctors, nurses, admin staff, so on and so forth. In addition to this, there will be also support areas. What would areas be doing? They will be looking after, let's say, diet preferences, the cafeteria, the kitchenettes, the storage, right? Regarding the cafes. The sterile services. If the, let's say, instrument is used in a surgical unit, that instruments cannot be directly used on a different patient. You have risk of contamination in the other patient and the other patient also getting sick, right? So for that, it goes to a sterile facility where usually steam is used to properly clean all of those instruments, and only then it can be reused in the operating theaters or wherever it needs to be used. Materials management. There is a lot of material that comes into the hospital. be it the surgical, be it the related to the patient, be it the linen, so on and so forth. Pharmacy. So usually hospitals have a pharmacy there itself, so that the guests related to the patient don't have to go outside somewhere. It is all in one location. You have the environment and linen services. There is a lot of laundry that happens, right? Every day the sheets on the bed sheets on the beds get replaced, the pillow covers get replaced. So these are basically cleaned in these linen services area. Of course, we have our department, the engineering and maintenance shops, that are making sure that the operations of the hospitals go on in format. And there is autopsy and more areas as well. After the passing away of a person, after the death of a person, if the police want an autopsy going on in that area or in the morgue area to preserve the cadaver. And then we also have the trash area where you'll have all the trash, be it biologic or just regular trash, properly segregated and then sent off for discarding with the appropriate vendor as well. All right. Now that we have explored so many areas of a hospital, let's talk about the special conditions that we need to maintain for a typical space. And we'll do a small exercise as well, because I see some folks taking a bit of a nap. So we have an exercise. I'm down. Special conditions in typical space hospital. So dear friend, as I mentioned, there are different codes and will be for ASHRAE 2021 standard, that is for the ventilation of healthcare facilities. It's not just like the International Building Code, even this standard is share my screen. Okay, so I'm sharing my screen. Can you give me a all good? Okay, so share. It's not showing up. All right, perfect. Okay, so talking about the code standards, I mentioned to all of you that ASHRAE 170 2021 standard is what we will be using for this particular problem solving. If this is focused on the ventilation for healthcare facilities. Okay. Then we have the Facility Guideline Institute. Unlike the ASHRAE standards, you have some limited views on the FGI guidelines. And also one more thing, there are a lot many standards that involve building the service, the MEP services for a hospital. These are just two, and each one has their own space and own scope in a given building. All right. So FGI guidelines is one of the guidelines that we use in the field of hospitals. There are also NFPA codes. We'll talk about NFPA as well. There is a National Electric Code. We'll talk about that as well. There is International Plumbing Code. We'll talk about those as well. But for the sake of the ventilation, the HVAC part that we are trying to deal right now, we'll do this particular space. Okay. Just a minute. Okay, so let's do some problem solving. For this problem solving, what I want you to do is, and even for the folks online, what I want you to do is go on to Google Chrome and search for, on Google, search for ASHRAE read only. Can you please search for ASHRAE read only on Google? Just let me know once you have the visual experience. And online, put it in the chat window if you can. If you are able to read only on Google. Sorry? No internet? There's the bar. So anyone got access yet? Do you have the access to this one? Anyone? No? Yes? Okay. How about you? How about you, sir? Do you have access to this? Okay. How about you? Not yet? Okay. Internet. Maybe try it for this one. It's called, it's not connecting?
Not available.
Okay, it's not connecting yet. So can who has the access, can they raise their hand? You have it, right, sir? How about, okay, 2, 3, okay. Anyone from this part of this thing? Anyone from here has access to the website? Google? No? Maybe try to turn on the hotspot. Maybe we can look into each other's laptops and check what is going on, because this is kind of a problem solving collaborative effort as well that you need to do again and again. Read. Okay, looks like so maybe just look up and we'll try to do a small exercise, and then we'll look into the aspects that okay. Everyone come on. Yes. All right. Perfect. And someone online as well. Can you please? You are able to access this website of preview ASHRAE standard. So let's get started. This is the queue for the folks that have joined online as well. So I'll start sharing my screen again. Hopefully everyone has had good coffee and tea. sustain. Okay. All right. So before going to the break, and before going to the break, I had mentioned regarding the international building codes. So this is just a collection of all the building codes that are used by different states in the US, as well as Canada, as well as all throughout the world. So if you see, there is a building code for Hawaii over here. Again, you have like the energy conservation code, which is based on the ASHRAE 90.1. You have international building code, energy conservation code, residential code. Just like that, different countries will also adapt the international building codes. Like over here, you will might have Ghana adopting the Ghana building code for building and construction, right?
Right.
Well, Rwanda is there. I don't think Rwanda has yet. Yeah, I was trying to search. I did not find Rwanda. So maybe all of the team members in this classroom sitting over here can push for the Rwandan code as well to be enforced. But yes, as you see, there are different countries like Saudi Arabia also has a set of building codes. They go much more into granularity in Saudi Arabia with the fire code, green construction code, the soils and foundations, sanitary mechanical code, building code, so on and so forth. But this is basically what I wanted to show you guys. So now going back to where we had left off. So we were trying to do quick problem solving. I assume now everyone has access to a working internet connection. So what I'll do is I'll open the website. So can everyone please do a thumbs up and confirm that everyone has access to this website? Also on the online folks, if you can just type it out in the text box that you are able to access this website. It will show up after you go on to Google and search for ASHRAE read only. That is ASHRAE and read only. So everyone has access. Okay. All right. Perfect. So now, with that being taken care of, as I mentioned, these are the codes and the guidelines given by ASHRAE. These are based on the experiences that the engineers that are working on these kind of projects have come across. All right. So like this one is the guideline 28 for air quality within a commercial aircraft, right? This one might be the representation of performance data for HVACR and other facilities equipment building. The one that we will be focusing on is the standard 170/2021 ventilation and healthcare facility. So if you click on it, the ASHRAE 170 standard, ASHRAE 170, let's go on to, there's my ASHRAE 1, let's go on to 2017. Let's go on to 2017. Yeah, do you guys have it available?
Yes.
Yeah, over here, ASHRAE 170 2021 or 2017 is also fine. Not a lot has changed between the codes. Once you go on to that, you will have to register. So you can simply enter your, you will not be spammed by ASHRAE for having the information. They just want to make sure that whoever is logging onto the website is genuine and no AI focused website is pulling the data from ASHRAE. So once you have filled in all of the data, please go ahead and submit over here. Once you click on submit, anyone you can use consulting engineers design, that's fine. Right. Please give me a thumbs up once you have access to this kind of standard where it says. Yes. Right. Anyone else wants more time? Everyone is set. Can I move forward? No, not yet. Okay, please. Anyone needs more time? You have any issues? So it doesn't matter what you select, it's just looking for a valid ID for you to log in. Yeah. It was just, it's not a registration, they bring on. Yeah, exactly. You can. Technical engineer, it's actually a recommend that. Yes, you need to. Yeah. And don't worry, you will not get spammed with yes, get there. This will be 84. The folks online, please do let us know if you have any issues. We will try to resolve it before moving forward, because we need to do a small exercise based on what we are talking right now. Everyone good? Everyone in the room has access? All right. So can we move forward now? Yeah. How about the folks? So do you have access? Yes? Okay, let's move forward then. Okay, so this is what we need to do, and this will tie up into the Revit exercises that we will be doing later on as well. So over here on the left hand side that you see, you will see a bookmark over here, bookmark option, right? In that bookmark option, go to the space ventilation dash inpatient services. Once you click on it, it will open that inpatient service on your screen over here, which will bring you to a table like this. Everyone has access to this? Anyone needs any help? Need any help over here? This is going to be parts. So we drop this down and go to space. Anyone needs help? No? All right. You need help? Emmanuel, anyone online facing any issues? All right. Okay. So here is what we need to do, which ties up into the HVAC design for hospitals. This is a chart that will give us the information regarding the conditions that we need to meet for the given spaces. So dear friends, this is a free resource, so it has limitations. I'll not say it is very user friendly right away. So you might need to tilt your head to check what is going on, because the purchase versions are like $200, $300, which of course I cannot afford. So I go over here, US dollars, by the way, and it is rising every day, right? So, okay. Now what you guys to do is maybe write down these three areas over here. The operating rooms, on your notepad, write it down. Operating rooms, patient rooms, and toilet room. Okay. So we are going to do an exercise and try to find the values for these three rooms. And the values that we will be finding will be the pressure relationship to the adjacent areas. All right, so make sure you write this down as well. We need to find the pressure relationship to adjacent areas for operating rooms, for patient rooms, and then for the toilet rooms. You can take a picture of this as well if you want, that's fine, on your phones. You will also need to find the minimum outdoor ACH. As I mentioned in the earlier session, ACH means air changes per hour. In some part of the world, it is also called ACEH, but the definition stays the same. Then we need to also check from that table itself the minimum total air changes per hour. One more thing that we need to find out is the minimum filter efficiency. And last but not the least, the design temperature in degrees centigrade. All right. So let me give you a quick tutorial of 170 table so that you can jump into it. We'll have 10 minutes for you to find out the answers to this, and then we will track those on the table as well. Okay. So going back to ASHRAE 170, as I mentioned, this table will give you different types of areas over here. Okay. So like in this case, it's the nursing units and other ERs, patient care units. In that you have sub-classification for all anti-rooms, the combination of AII. AII is the isolation rooms that we talk about. Then we have the emergency department, but you need to find out something called as an operating room. Now I've given you a straight answer over here. There is an operating room over here, the same operating room that you took a picture of. Now this operating room, if you check there, it has different parameters over here. Okay, this last row is for operating room, which has different parameters. And if you go up the column over here, you'll have pressure relationship to adjacent areas, right? So you check what this is, and then we will write down in the in the table that we have. All right. Just like that, you have minimum outdoor ACH, air changes per hour. You have the minimum total ACH, air changes per hour, minimum total air changes per hour. Then you will have the minimum filter efficiencies as well that we need to find out. And in the end, we need the design temperature in degree centigrade. So whatever is before the slash, is degree Fahrenheit. But we need to check what the numbers are for the degree Celsius or degree centigrades. Task clear? Understood? Okay. There are many pages. So please go through the pages, try to check the area that we are looking for, right? And then we can do a 10-minute wait. You guys check it out. If you are done, just let me know we are done. I can then move forward accordingly. All right? Yes. Any questions? Yes.
Which show was the typical?
Sure. Let us focus. Once it is open, you see the internal concept of spaces, then you need to click on the cluster, click on clustering techniques, clusters. Then go to 7. So you also accept it over here. So you mentioned you want to see the table.
Yes.
The from the presentation, right? Very good. And please note, you can collaborate with each other. This is not like an exam or anything. You can collaborate with each other. If the folks online have any questions, please post it in the chat box. We'll make sure we resolve those questions. So now you have access. Yes.
These are equipment design. If you are done, please let me know we are done. Please take your time. We'll have 10 minutes for this.
Okay, so a question from Tony. I have not gotten how to check the table. Okay, Tony, I'm going to explain it to you once again. So this is the table, Tony. Over here on the first column, there are columns and then there are rows, right? In the first column is where you will find the type of areas, right? So the type of areas that we are looking for are three types of areas. From my presentation, if you check, you will have the operating rooms, you will have the patient rooms, and you will have the toilet rooms. You have to identify where that patient room, toilet room, operating room, whatever it is in this table. Then follow this road to find out the relevant parameters with that particular type. Then to find out the relationship adjacent to the areas. Next parameter. So basically, if you have areas, the pressure relation. Okay, everyone done? You have a question?
Finishing that. I want to see if you can write this.
Sure, yeah.
Yeah.
Okay, yeah, that's what we need. So, okay, one last minute, okay, then we'll go move forward. There is still a lot to cover and we are already 6:45 today. I need to make sure that I send you back home on time as well. Keep you waiting too much. Or tomorrow it will be too late then. All right, Tony, thanks for the feedback. All right, let's check the answers. It's fine. You guys can do it later on as well. This is just something to make sure that you understand the concept and how we are going to operate for the heat load calculations that will be a part of tomorrow, so that we can start analyzing in Revit as well. Okay. So, okay. Can anyone give me the first operating rooms? What was the relationship to adjacent areas? Any sorry, positive?
Yes.
Okay. How about the minimum outdoor air changes? 4. Good. Minimum total ACH?
10.
How much? 10 or 20?
20.
20? Okay, all right. Minimum filter efficiency?
-16.
MEP 16. Okay. How about the design temperature? Okay. Good?
Yeah.
All right. I'll explain everything to you in a moment. Let's talk about the other two areas first. Anyone from the... okay, I've already displayed it. But patient room is NR. We'll talk about NR in a moment. The minimum outdoor air changes for patient rooms is 2. Minimum total air changes per hour for a patient room is 4. MERV rating is 14, and the design temperature is 21 to 24 degrees centigrade. Is this what all of you got? Perfect. Okay, so I want some feedback from the folks online as well. Can you please let me know regarding the toilet rooms? What is the answers you have gotten for toilet room? Maybe someone can unmute as well. They can unmute. No, or maybe you can type out in the text box and let me know. Yes, toilet room. That's correct.
Okay.
Maybe you can type out one after another. Yep. Negative pressure. Yeah. Next. About the minimum outdoor air changes per hour. Okay. How about the minimum total air changes per hour? Okay. How about the minimum filter efficiency? I'm also. Okay. How about the online folks? Any response from you? The minimum filter efficiency. Okay. And last but not the least, how about the design temperature in degrees centigrade? Okay. All right. So this is what everyone is getting. Yes. All right. Okay. So I tried to take an effort to make sure that I have all of the areas that you usually will come across. One among them is a super safe environment, you can call it, like an operating room needs to be as not as indoor environment quality friendly as possible, followed by patient room. In the end, the toilet room, which is considered as unclean area when we talk about hospitals. Okay. Let's talk about the first one, the positive pressurization. I brushed on this topic earlier as well. If you have 100 CFM coming into a room, you need to have lesser CFM that is being returned back to your air handling unit. That will maintain a positive pressure, right? So many a times it happens that you try to go to open a door, right? And then the door directly goes open. That's because the air pressure is positive and it's pushing from the inside room to the outdoor areas, right? What that does is the buildings are not always properly sealed, right? So when you have a wall and when you have a floor, there is a minute crack in like microns that is still there, which is called as the infiltration area. So the outdoor air seeps into the area and that contributes to heat loads, right? So if you try to positively pressurize the area, and in this case specifically the operating rooms, the operating theater, you're avoiding the outside contaminants to come into the operating space, right? Yes. That is one point. The second point is regarding maintaining a laminar flow in your operating rooms. Okay. Going back to our studies, 3 types of flows: laminar, turbulent, transient, right? Based on the Reynolds number we are talking about. So when you have the operating room typically has one central patient bed. It will have big booms, surgical booms they call it, right? On the top, the doctors and the nurses will be around the table doing the surgery, right? So in that case, you need to make sure that the air that is coming from that surgical boom is properly laminar. It does not mix again and again. We don't want that happening. Mixing is just giving option for the contaminants to go into the surgical area, right? And that is how you will create a laminar flow. Usually in an operating room, the returns are low. It is not up high. It is low. The air coming should have a unidirectional path so that it does not get a chance to interact with any other air. Yes. Okay, there is a question. My table shows not required. How did you get 26? Okay, so give me just a moment, Peter. I will go one by one through the table, and then we will discuss what about the 22 to 26 degree for the toilet areas. Okay, so talking about the next thing is patient rooms. Okay, so the patient rooms will usually have an isolation area, right? There will be a patient room. If the guests are visiting the patient, they will need to go through an isolation area, also called as anterooms, so that the amount of cross-contamination that can happen between the corridor and the patient recovery room is reduced as much as possible. In that case, we have the NR. NR is not required. Okay. So just to give you an idea, if you go back to the code over here, usually you will find this very typical in any given code. Okay, they will cross-reference all different areas. Okay, so for that, when you see a CC over here, right, those CCs are like the footnotes. So if you go at the very bottom of the table, you will have A, B, C, D, whatever, and then you will also have a CC. Let it load first. So the CC is over here, and it will give us more information regarding what that CC means. All right. So going back to the table, NR, I said, is not required. It can be positive as well. If negative is fine as well, but make sure that if the patient room has an attached toilet room right next to it, the patient room as compared to the toilet room needs to be positive, right? We don't want it to be negative because we don't want the toilet air to come into the patient room. Toilet room, unclean air, right? So that makes us come to the next point, that is regarding the toilet rooms. So whenever you have a toilet room, trash room, that will always be negatively pressurized as compared to the adjacent areas. We don't want the air from the toilet room going outside, where it can create more issues. We want the outside air to come in. Make sense? Next, talking about the minimum air changes per hour, minimum outdoor air changes per hour. So I had a brief conversation at the other desk, but basically the outdoor air is what keeps the carbon dioxide in check in a given room. All right. We'll take an example of this conference room that we are sitting in. This is what, maybe a 50 by 15 foot conference room with around 10 foot ceiling height, right? There is a volume, right?
Yes.
50 feet into 15 feet into 10 feet. Whatever that comes, it's cubic feet, right? So how many air changes per hour we need? We have a formula for that. We'll go into the formula as well. But that basically means how much air changes we need from the outdoor air into the indoor air. Does that make sense? Why we need it? To keep a check on the CO2 levels in the room. If we have too much CO2 level build up in the room, it will lead to dizziness, sleepiness, drowsiness, so on and so forth. Right? Now, the next column is regarding the minimum total air changes per hour. Okay. So this is just outdoor air we are talking about. The air that we are bringing from outdoor to the indoor to make sure that the indoor air quality is maintained. Okay. Yes.
So how can you measure the air changing per hour?
Yes. So the question was for the online folks, how can we measure the minimum air changes per hour? So first of all, we'll need to have the formula for it, which will give us a CFM. And based on that CFM, then we will have airflow measuring stations that will measure how much CFM that is being moved in a given particular room. Does that make sense?
Okay.
All right. The total air changes per hour, we are talking about now the air changes per hour required to maintain the room at a given relative humidity and temperature conditions. All right. If we have too much humidity outside and we are bringing unconditioned outside air indoor, the humidity in this room will rise, right? When the humidity rises, it gives rise to pathogens coming into the room. Water droplets have more capacity to carry pathogens as compared to dry air. All right. So that is why we use the minimum total air changes per hour to take care of the building load, the heat load of it. Right. Minimum filter efficiency. This is one more thing, and you might have come across this term called as HEPA. Right. High efficiency particulate filter. Right. So now HEPA is MERV 17 or above is HEPA filter. Okay, and MERV is minimum efficiency rating value filters. Right. Now, if you see over here, the operating room, and this is the minimum filter value. The more up you go, means you're going better than the minimum, right? Which is always fine. But you need to have MERV 60. But the industry standard will say give a HEPA filter for the AHUs, the air handling units serving the operating room. Okay. So more often than not, HEPA filters MERV 17 or above will get specified for an operating room. Right. Now, talking about design temperature, as I mentioned, all of our spaces will need to maintain at a given environmental conditions. Okay. If it is too high, we run into the risk of the patient sweating more, getting exhausted more, getting dehydrated more. On the other hand, if it is too cold, the heat loss from that patient's body will be much larger. And as I said, patients are very scantily cladded in a given hospital area. So we need to make sure that the temperatures are also met over here. Okay. Does that make sense till now? What we are looking for? Any questions? I am coming, Peter, to your question as well regarding design temperature. Give me just any questions till now on this table, how to find information. Yes.
You know, the difference between minimum order of ACH and the minimum
total, right? Okay. It is different. Yes. So again, as I said, when you have an air handling unit, let's talk about a general air handling unit, not just for the hospitals, right? So you have a supplier stream, right? That supplier stream, if you check a ventilation air or outside air, right? So that supply air comprises of the total minimum total ACH, as well as the component of the outdoor ACH, right? I'll show you a schematic. This is a bit ahead in this thing. Okay, so we'll talk about this as well. But this is basically a schematic. This is coming. This is not something that is right now. This is later on in the lecture. But this is a schematic. Everyone knows about a schematic. Yes. Okay. So this is a schematic for a general constant air value. No, it's just a general air handling unit. All right. So over here, as you see, this is where the supply air is moving into the area, right? This is where the return air is coming back to the air handling unit, right? We have a relief so that we do not over pressurize an area. And then you have the outdoor air coming into the air handling unit, right? What goes out of here is the minimum total ACH. What comes in from here is minimum outdoor ACH. So the total ACH will be a combination of the return air and the outside air. Is that making sense? Okay. Okay, going back. Oh boy, there's too much to cover, to be honest. Okay, so any questions on that table or any other parameters before I take up the question from Peter online? Any questions? Any questions from you, sir? Yes.
Now, you can do the particularity of HI to the HI is
yes.
Then we this test to depend on environmental conditions.
Correct. Yeah.
Now, America is and the one Rwanda, they have different climate, different conditions.
Yeah.
Is it still applicable?
Yes.
It has to be this
So the outdoor air conditions. So yes, first of all, to answer your question, yes, it is applicable. I'll tell you where the difference comes in. So difference comes in when we are talking about the heat load calculations, right? And the heat load calculations when we'll be doing the heat load calculations as well in E20 spreadsheet. But that outdoor conditions that will come, oh my goodness.
Just like
This one, right?
again, yeah.
I passed. So okay, now this is where we will come into the environmental conditions. Okay, this will be more applicable for heat load calculations. Okay, so heat load calculation, as I was saying, the formula Q equals to mCp delta T. Okay, over here the M might be the CFM or whatever be the case, the LPS or whatever be the case. CP is the coefficient, the coefficient of heat transfer, and the delta T we are talking about, T2 minus T1, right? T1 is the temperature, the design temperature that we want to set for the room, and T2 is the outside temperature, right? Now, talking about this, stop. Okay, so Kigali city, Rwanda, we have certain, these are the measuring stations for the air data that we have, and it is for throughout the world. Okay, so over here we are talking about the closest airport. Usually the closest airport, an airport will have a weather monitoring station. It is called weather monitoring station. So this data, if I click on A, it will bring in the data, historical data. Okay, this is not just data for today. This might be data ranging from 10-20 years back. Okay, now if we debate it or not, global warming is real. Yes. The temperatures are slightly increasing every year. Okay, I've got projects in Saudi that worry about those peak seasons, and then it becomes very hot over there, and the HVAC unit cannot sustain the load. Right? In that case, this comes into picture. All right, and talking about the cooling. All right, so the hottest month, as per the data, is August in Kigali. Okay, and in the hottest month for 0.4% time, okay, the temperature will be 30.2 degrees centigrade. Dry bulb. Is that making sense? So now my air handling unit, my HVAC system that I'll be designing, indirectly my cooling coil that I'll be designing will be for 30.2 degrees centigrade outside. Inside, let's say what did we have previously? $21. Okay, yeah, 21 we are talking about, right? So 21. So 30 minus 21, right? The 9 degree, right? So that 9 degree is the delta T that I'm calculating. Of course, that air is also going to be at 30.2 degree. But my fan, the coils that I have in my air handling unit will be sized for handling that load as well as the return air temperature that is going on, because it's going to mix at the end of it. That 30.2 degree is going to reduce and meet it halfway wherever that proportionate angle is for the return air. Because the return air that we are trying to maintain is at whatever 24 degree, 21 degree. There will be a set point for a room, right? And that will be the return air going back to the air handling. Does that make sense? Oh. So, but that cleared your doubt, right?
Yeah.
Okay. Relative humidity, yes. So relative humidity, we have to look into that as well. But you need to classify, you need to specify the relative humidity that you want to maintain in a given space. That along with the set point, we will give that to the vendor. He will do the selection, because nowadays the coils are getting efficient as much as possible due to the different materials that they are using. And based on that, they will give us an answer, what we need to have. So that coil will basically take care of condensation, of the excess humidity, as well as drop down the temperature to whatever we need, the 20 degree or not 20, we'll need to bring it down a bit more so that the supply air temperature is lower as compared to the return air temperature. Does that make sense?
Yes.
Are you sure? Perfect. But great question. Yes. So we'll talk about the ASHRAE Material website as well. Right now it's already 7. I still have a lot to cover. But tomorrow we'll try to do as much heat load calculation. We have a full floor plan of hospitals set for you. We'll go through the E20 spreadsheet. We'll use that ASHRAE Material website. The full works. All right. Okay, sorry. So we were talking about Peter. I'm so sorry. Let me explain to you where we got the 22 to 26 degree for a toilet. Okay, so just for everyone in the room to know, Peter had asked, how did I get the 22 to 24 degree? So let me go at the first page. Previous page.
Again.
Oh, more. No.
But it's the same patient toilet and
Which page is it? 16, 17. Okay.
Yeah.
yeah.
Toilet.
No.
No,
17.
toilet area.
So 17.
17.
17.
17. Okay.
17. Yeah.
17, right? Okay. So thanks. So Peter, here is the toilet room that we are talking about, right? Negative pressurization. The minimum outdoor air changes per hour is not required. The minimum total air changes per bar 18, and we are looking at the design temperature at 22. Right. Understood. So okay, yeah, that is a very common trouble that we as non-American come into picture during the non-American projects. The matter of fact is there are only so many weather stations out there, right? But I do understand that you might come across the instance where what you have noted is not matching to your project areas. Okay. So in that case, I would recommend, this is what I do. I try to take the weather station which is closest to the area that you are trying to find. Okay. So, okay. Okay, I understand your conundrum. Yeah, there is no closest to it. So yeah, even these areas will give you wrong information. Yes, I understand your problem, man. Yeah, it's Kigali that I would recommend using, because I do understand that temperatures in Kigali will be a lot more as compared to what you have in the northern part of the country.
Yeah.
Okay, we'll open another topic over here. This comes to liability as well. Okay. We as consultants carry a lot of liability because it is our design that we have put in so much effort. And a part of reason I'm explaining so much is because I want you guys to understand the basics as well, so that later on, if someone questions your logic, this is where the logic came from. But anyway, talking about the liability thing, if your design gets questioned in the court of law, right? You cannot go up to the weather station D or weather station B to make them understand that that is better as compared to what you have in A, weather station A. Right? But I do understand your problem. I do understand you. Maybe you can work with the government to set up a weather station over there. Okay. Support. Okay, all right, perfect. Let's go back to the presentation. Now we spoke about HVAC in particular, the design consideration for 3 typical spaces, very commonly found. So I think so it's a good exercise for all of us to understand where the information is coming from. Okay. Next, we are going to talk about a hospital. Okay, I want you to understand, and it doesn't take me it gives me sadness to give this news to you that in a hospital there was a surgery going on. Sorry, screen is not visible. Oh, sorry, no, it's saying it's sharing. I'll share it again. Okay, how about now? All okay. Okay. So over here, this is a state in my country, Punjab. In India, there is a state called as Punjab, and during a surgery, there was a power outage in the operating room. The patient was on the table. There was a power outage. And this happened on 26th of January.
2025.
2025, yesterday.
Sure.
Right?
Yesterday.
It's not even like that archaic that it will be too much. But just think about what can happen in this situation.
Yeah.
So that is why I wanted to take this topic with all of you, and we'll discuss this in detail as well regarding the emergency power supply, talking about electricity. We spoke about HVAC. There's a lot more to cover about HVAC, but I'm specifically targeting the special conditions that are required in a hospital. Okay. Now, can anyone explain me when the utility has power cut to a building, what happens in that case?
There's a backup generator and UPS.
Backup generator and a UPS, right? And UPS, right?
Yeah.
Uninterrupted power supply. Right?
Yeah.
So which one would be more reliable? A generator or a UPS?
So both.
UPS?
That's UPS, yeah.
Why? Sorry?
It gives a clean match.
There is an interruptible power.
For generator, there is a startup time. This startup time makes some equipment in 40 hours. Just hope.
Yep.
like those is coming and what they are all
Yes.
is starting them to be back. So you
Exactly.
get at least for the time for the start.
Exactly. Anywhere between 1 second to 10 seconds is required for a DG set to start during your work. There is an automatic transfer switch that needs to operate on an electromagnetic principle that takes anywhere between 1 to 10 seconds. And we are talking about a patient that is on the table, right?
Yeah.
But in the case of UPS, it's split second. All right. It can hold for the 10 seconds that the DG can start, but it is always good to have the surgery rooms, the operating theaters on UPS as primary.
Yeah.
Okay. So that is where the devices such as diesel generator, the uninterrupted power supply will come into picture. Okay. So this is a short schematic, I would say, not anything in detail, but we will speak about that in detail as well. Of course, you will have the DG set. You will also have the main supply supplying the power from the switchboard, distribution panel, whatever it is. You will have the automatic transfer switch over here. And then we will also have the UPS. The UPS is going to serve the critical nodes. Right?
Yes.
Lighting, office circuits, air conditioning for non-critical areas can go on DG set. But critical loads need to go via UPS. So, special consideration for hospitals.
Yeah.
Now, when talking about plumbing for special considerations, we have medical gas, right? Medical gas is regularly required. Some examples are oxygen,
Yes.
respiration that we require, right?
Yes.
Carbon dioxide, nitrogen, nitrous oxide, right? Just some to name. All right. So these are some of the typical medical gas, med gas. They are used. The terminology is used interchangeably. Okay. So this basically concludes what classifies as a building, as a hospital. Sorry. We are almost 7:30, right? Gorky and Emmanuel. I know you have given me up till 8. So I'll try to restrict to 8. But I want to speak about in detail regarding the different types of HVAC systems that are used in hospitals. Okay. Those are another 20 slides, but the talk is worth of half a day more. So I'll try to wrap up as much as possible. But tomorrow I'll try to make the compensation for it. Anyway, any questions till now before we jump on to discussing in details the HVAC systems used in hospitals? No? Anyone online? No, okay. All right, so let's move forward with HVAC systems in hospital. Right now, what we were looking was very basics of all the trades. It's not just HVAC, very basics of electrical, very basics of plumbing. Now we are going to go ahead and check the specifics in HVAC. What type of HVAC systems are used in hospitals? Of course, why they are used, we have spoken about that, but I'll repeat myself over there. What system to use during what time, that also we'll discuss. Advantages, disadvantages, that we'll discuss. So that if you are presented with a particular area in your project, you can go through it and try to make sense of it, because we as engineers always need to explain it to the people whom we are giving the solution, right? So, okay. First of all, as I mentioned, the importance for maintaining thermal comfort, air quality, and humidity. So a typical HVAC system in a given hospital will juggle tasks like providing the correct indoor air quality, right? We are talking about HVAC, so it is indoor air quality. When we are talking about a holistic thing, it is indoor environment quality. Okay. Next is regarding the heat loads from the facades, right? The exteriors of the facade, the walls that we have, the windows that we have that face the outside conditions. Those are the heat loads. Now, the hospital HVAC systems, we need to make sure that we meet or exceed the demands of application. Since hospital in themselves have different areas which are unique to its characteristics. The most important thing that we are talking about is all the systems working as an integral system to make sure that the building's process is properly assigned, to make sure that human life can be saved as much as possible. Now, there are a variety of HVAC systems that you'll come across in the hospitals. Let's go ahead and check one by one. So these are some of the fundamental differences. Okay, there were the conventional systems like let's say the hotel HVAC system, office HVAC system, but those are conventional. What we need in hospitals is far different. Why is it different? We need to maintain the relative pressurization between the areas. We saw the positive, negative, not required, right? So it is very critical for the hospital HVAC systems to maintain those. Along with that, the airflow is from clean to less clean area. We spoke about toilets, right? The air cannot go outside of the toilet. It needs to go inside of the toilet. Right? Clean to less clean area. The filtration. If you are designing, let's say, an office building, a MERV filter of 8 to MERV filter of 12 is more than sufficient. You don't have to hit the HEPA filter mark just because there is no need for it. In the hospitals, we have ill patients, and that is why we try to push for HEPA filters, right? So the special considerations that come into picture when talking about the operating rooms, again, precise temperatures are required, as we checked from the table. Precise humidity controls are required, right? Space pressurization is required. The filtration of supply air is required. And there is limitations to allowable circulation air. As I mentioned, it needs to be a laminar flow. You cannot recirculate the room with the same air. It needs to go out. Ventilation effectiveness, as I was mentioning, the minimum outdoor air is per hour that we require. And again, when we are working with such a specialized application, we are posed with different type of restrictions, like do we use a steam system or do we use an electric system to increase the temperature, right? But if you use the electric system, how do we increase the relative humidity if the relative humidity is too low, right? So all of these are different challenges that you'll come across when you're working on a typical hospital building. And last but not the least, the design for HVAC that is properly in tune with the conditions, space conditions, will be reliable in operation, will have consistent temperature, humidity, and outside air volume. And then last but not the least, and I think so the facilities engineer in the crowd will weigh in on this. If you don't have proper maintenance space, it's going to make a lot of problems for facilities people later. Okay? So it is our responsibility as consulting engineers to put that clearance areas everywhere for proper maintenance. All right. So the top 2 points we have already discussed. So let me get into the main topic now regarding the HVAC systems that we have. So ASHRAE usually has 3 basic categories for central HVAC systems. First one is all air system. The second one is air and water system. And the third one is all water system. Okay. There is one more in addition to this, but I have purposefully not included in this tree over here. I will explain you the reason why. And the third one is basically the direct expansion refrigerant system. Okay. On the next slide, I'll tell you why. But the DX system, VRF system, you must have heard about VRF, right? Variable refrigerant flow. I think so. Daikin calls it variable refrigerant volume, VRV. The reason why these are not preferred in hospitals is because they are limited by ASHRAE 15 standard as well as the local codes. Okay. This is the reason why it is limited. Okay. The most commonly used refrigerant, right? So every HVAC system will have a refrigerant flowing through it, right? The most commonly used these days is R410A, right? We have 410A somewhere. Where is it? Yeah, over here, right? This one. And by the way, it was in Kigali that the agreements were signed to phase out the carbon fluorocarbons and hydrofluorocarbons, right? So we should take pride that we are in that city. But despite that, the thing is, the refrigerants will range on the flammability as well as toxicity. Okay. Flammability means if the refrigerant is leaking and it just finds one spark, it has capacity to ignite by itself, right? And on the part of toxicity, this is toxicity for humans. If we inhale that refrigerant, we will fall sick, right? So now the reason I made sure that I have this last point in a separate and not this one is because we need to make sure that in a given space, all right, as we'll talk about that as well in detail on one of the slides regarding DX system. In a given space, again, we are talking about a volume. A maximum number of kgs of that refrigerant can be allowed if there is a leak. Okay. So these units, if there is a leak and there might be 1 kg of refrigerant in there, in this given space, a maximum of that much kg of refrigerant can be allowed to leak. If it goes above that, that might cause human hazard. All right. And we are talking about hospitals here. It is better to have refrigerant somewhere else, bring in chilled water to the systems rather than directly expose the conditioned air to the refrigerant. And refrigerant leaks, dear friends, that is very common. Right? Okay. Now, what time is it? So we have 25 minutes. Please let me know in advance, okay? Because now I'm going to go in a flow and there will be a lot of interesting discussions going on. So we spoke about 3 systems, right? All air, air and water, and all water. We'll speak about the all air systems first. Now the all air systems will be classified under the constant air volume. By its name, it suggests that the amount of air that we are pushing through the air handling unit will be constant. Okay. So this is a choice for the patient care areas, the areas that we had discussed right earlier. The design is very simple. You don't need to have many transitions in the ducts going on up and down. The coils are pretty straightforward because it is a constant volume that you'll be pushing through the system, right? And on the other side, we have the variable air volume, right? Variable air volume will be very helpful where you are trying to maintain the pressurization because that will play around with the controls, right? So now think about this. You have an operating room let's say you have 10 operating room in a hospital. Out of that, only 3 are being utilized, right? So with the variable air volume system, we'll talk about the system in specific. You can just keep the variable air volume devices for those 3 operating theaters on. Rest 7 can be off, right? But if you're doing that, you need to vary the airflow that is going just through that 3 VAV devices, right? So for that reason, it is very popular when it comes to proper pressurization with the help of proper controls as well. Now, as I mentioned, this comes in very handy when you have to do some kind of pressurization, right? When we spoke about this pressurization in the operating room, in the restroom, so on and so forth. So wherever you have a pressurization that you need to maintain between a room and the given adjacent areas, variable air volumes will be what will be preferred, right? So these are the 2 broad classifications for a all air-based system. Now we'll jump into the next one, which is, okay, before going that, we'll come back to this schematic diagram. The reason I wanted to bring this schematic diagram is for explaining you a typical schematic diagram, okay? So, by the way, is everyone aware, has anyone seen a diagram like this in the past? A schematic diagram? Yes, right? Okay, all right. So I'll not push too much on this. So again, we have one stream of air going through here, right? This entire thing is basically a air handling unit, right? And we have different components in an air handling unit. Here you have the return air fan. There are some dampers. NC means normally closed. NO means normally open. We have an airflow monitoring station. We have the economizer and the minimum outdoor air inlet dampers. We have the heating coil, or the preheat coil also sometimes called. We might also have some steam jets. Okay, steam jets are usually used to maintain the relative humidity. Okay, if the air that we are getting at this point is too dry and we want to maintain a certain relative humidity, we can have steam injected into the airstream so that increases the relative humidity of that air. Okay. Of course, we have the supply fan over here. In our countries, it doesn't get that cold, so there are not many chances of elements to freeze. But let's say Canada, North of America, Russia, these countries get to very sub-zero temperatures. At that time, the freeze stat is used to ensure that proper monitoring is done for the airstream and nothing might lead to any freezing of the components. That is what it is used for. Next thing is the cooling coil. Of course, when you have heated it, the air will be quite hot. And then you need to cool it down if in case the supply air temperatures are not being met at this point of time. If required, you can have another humidification coil over here that is based on steam. Excuse me. Then you'll have a thermostat over here for measuring the supply air temperature. These filters will be the same filters that we spoke about, the minimum filtration efficiency required, right? There might be more filters coming into it as well as over here at the outdoor air stream, because we don't want outdoor air to directly come into the air handling unit. If there are minute particles that might cause failure in the stream up over here or over here. So that's why we have this upstream filter section over here. All right. And then we have the static pressure sensor in the duct trying to maintain the proper pressurization inside the duct. This is not pressurization in the room. Okay. If we have too much pressure, there might be punctures in the ducts that might happen. Too less pressure, it might mean the duct is collapsing inside itself. Okay. So this is what a generic air handler schematic will look like. Okay. Now over here, as you see, there is something called as a variable speed drive If it is DC motor, it will be variable speed drive. If it is AC motor, it will be variable frequency drive, right? Now this one is optional if you find it over here, okay? If you have those VFDs, VSD on the motor, variable air volume. If you don't have them, constant air volume. Make sense?
Yes.
Okay. All right. So now let's focus on the first one, that is the constant air volume system. Okay. Again, the constant air volume systems will be divided as single duct, the first one, with terminal heat. What does this mean? The duct going out of the air handler will be just one. Okay. That duct will be connected to individual ducts serving the areas. And in that duct, you will have a reheat. Okay. So the temperature out of the unit, air handling unit, might be somewhere around like 15 to 16 degrees centigrade. And then you will raise it or lower it, raise it because we are trying to use terminal heat. You will raise it to maintain what the supply air temperature requires to be at the zone. Okay. So that will be the entering air temperature into the room. Right? We'll talk about the advantages. So first of all, the HVAC equipment is centralized. You'll have one big mechanical room somewhere. You'll have one big duct serving all of the areas, concerned areas. So since you have one equipment that will be big enough, you're constrained with just one area that you need to worry about, and then that is basically the ease of maintenance that we are talking about. Since it is a central equipment, you can take advantage of the load diversity for optimal sizing. Basically, if you have just 3 operating theaters, 3 operating rooms in operation out of the 10, you need to run the AC, the air handling unit just to serve those 3, not all of them 10. Next, can use airside economizers effectively. Is everyone aware of airside economizer? What that means? Can I take that as a yes? Yes or no? Okay. Yeah. Okay. All right. It's becoming too much. All right. And then it provides a great deal of flexibility to serve multiple spaces. Dehumidification can be done properly, well suited for good control for even the ventilation air strategies, and there is an opportunity for high level filtration. Talking about disadvantages, reheating the cooled coil. Cooled air is not energy efficient, but if you need to maintain certain leaving air temperature out of the duct, we need to do this. First cost is higher as compared to a unitary system, and requires mechanical space in the mechanical equipment room as well as shafts. Now, we'll talk about the dual duct. Okay. I will just scroll through it, try to compare between this and the next one. Okay. So over here I had ease of maintenance. Over here I have ease of maintenance. Over here I have load diversity. Over here also I have load diversity. Over here I have airside economization. Same thing over here. Flexibility stays same. Good dehumidification control, yes. Good control for building pressurization is there. Ventilation air quantity is properly controlled, same. High level filtration, that is also same. Okay. So you might say everything is same, so why do we call it two different things? Okay. Yeah, we'll talk about that. So first cost, yes, that also stays the same. This is where it starts getting tricky. Now the acoustics, right? You will have 2 ducts. We'll check the schematic for this as well. But since you have 2 ducts, there is more chances of air being diverted, which causes noise. Okay. But this is even a smaller disadvantage than the next disadvantage that I'll be discussing, which is substantial duct space. Okay. How many of us have worked with architects before? No one has worked with architects, yeah? trying to grab space from architect, how hard is it? So that is where the main issue comes in for a dual duct. Okay, and that is why you will be seeing the single duct terminal heat at a lot many places. All right. Okay, so this is what a single duct constant air volume will look like. Oh, it's not that properly visible. Okay, so this is where you will have the return air coming in, right? In this, the return air fan, you don't see any VFD or VSD, right? You have the relief air going out. You have the economizer and outside air coming in. You have the upstream filter over here, preheat coil over here, the humidification steam jet over here, supply air fan over here, restart, cooling coil, another humidification control, supply air temperature reading, the final filter, the the static pressure filter, and now it is going to the distribution system. All right, you see just one duct coming out of it, and then this is a typical reheat terminal unit. So the air goes in, it is heated, and then it is supplied to a typical zone. All right. So even if the air is coming out at 15 to 16 degrees centigrade over here, and if you want to maintain a pretty 20 to 24 degree or whatever it is as per ASHRAE, you might need to heat it a bit more so that the leaving air temperature from here is adequate enough to meet the load of this area. We don't even want to introduce too cold of air in there, right? That is also not proper, because we also need counter heat to counter that cold air that we will be sending in. Make sense? Then we'll have the thermostat, which is maintaining the temperature of the given area. And this is where the return air will go back to the air handling unit. Any questions? Any questions online? Okay, there is something. Okay. Is it clear? I want to make sure that these are clear, because these are systems that we'll be using again and again in our career. Sure? Okay. Yes, please. Yes.
Necessary to reheat, right? Before dispensing
This one, right?
Yeah.
Good question. So for the folks online, the question in-house that we have is that we are reintroducing heat at this location. Let me get my laser pointer. After heating and cooling this air over here, when it comes down to this terminal unit, we are heating it again, right? That is just energy inefficient, correct? We are cooling it and then we are heating it again, right? So now, it is not necessary if the air handling unit is serving just one type of space. If it is all operating rooms, it might be okay. But if you are using that same air handler to serve an pre-operative room, a pharmacy area, laboratory area, the design temperatures over there might be a bit different. Okay, it becomes very crucial when it comes to the patient areas. The reason being, the air that is coming in 15 to 16 degree industry standard, or you can correct me if this part of the world it is something else. 15 to 16 degrees, we are introducing it into the room, right? When we have a patient who is trying to recover, their body heat is already losing at a faster pace. If we introduce that 15-16 degree air into that same area, right, and the outside loads are not countering that cold air, the heat will be transferred from the patient's body, right? Hot to cold. So that is why it is fine if you do it. But we need to understand the function of the space that it is going to. In the patient area, it would be better to get it somewhere around like 20 degrees centigrade, so that it is not too cold when the draft is coming down, and then they get too sick after that.
This is actually a normal operation. I know the heater is necessary. The problem was if it is just necessary for every but if it has to be controlled depending on the required temperature in the room.
Right, exactly.
Thinking it is compulsory.
No, not compulsory. If there is enough evidence that you do not require and a colder temperature is fine putting into the room, it is fine. But I would recommend, if it is a patient room, give it so that you can modulate the air properly, modulate the temperature of the air properly over there. Right? Okay. Any questions on this system till now? All right. Is the electric or even steam powered, hot water powered, it can be anything. But yes, at the end of the day, we are cooling it and then we are heating it again.
Yeah, we use
Yes. It depends on the type of fuel that is available as well. In Northern American countries, they have natural gas readily available. And their government also allows them to use it. In some part of the world, the government has banned the gases to be used in HVAC. So that might also be the reason. So it can be electric, resistive element. It can be hot water from boiler. It can be even steam from a steam boiler. Okay. So we will take this last one and then we will call it a day. All right, Emmanuel, Gorky, we'll take this last one and then we'll call it a day. So just like we had discussed the single duct, now we are talking about dual duct. Okay. And again, dual duct, we as engineers will love it all the time. But when we sit on the table with the owner, with the architect, it's always the other side that ends up winning, because it's a bit more costly because there are more moving parts, controls comes into picture, so on and so forth. And the biggest thing is, of course, the space. All right. So just as we have seen earlier, we have the return air plan over here. Now we are talking about the CAV, constant air volume, or variable air volume dual duct. Okay, it stays the same. Just the introduction of these variable frequency drive or variable speed drive gets introduced when we are talking about VAB, right? Now over here we have the return air coming into the air handling unit, return air fan, relief air plenum, outside air introduction into the air handling unit, the pre-filter over here, heating hot coil, the steam humidification nozzles over here, supply air fan, freestat, another set of steam humidification coil. And now this is where things get different. Over here you have a heating coil, okay, and the other part is the cooling coil. All right. We have the temperature sensors, we have the filters, and then we have the static pressure sensors. Now at a given time, it can happen that both of the systems are on, heating, cooling, both are on. They go into this dual box VAB, and then the temperature sensors over here will take care of modulating how much air from both sides need to be introduced into the zone. Does that make sense? 2 ducts coming out and 2 ducts going into the VAV box. One is the hot air duct, one is the cold air duct. Yes, you had a question? Yeah, that's what this system very good for controlling precise temperatures, precise pressurizations, but it is not. I'll be honest with that. And as I was saying, when it comes to the tug of war between architects, owners, it's usually the other one that ends up winning. All right. But in case it is required and there is budget for it, like if you work in a project for Dubai or Saudi Arabia, for some reason they always have a budget for it. So I love working in that area. And not just for the building, even for the consultant, they have budgets. Anyway, coming back to this system, the dual duct. Now the temperature of the air coming out is again properly collaborated with what is required at this set point over here. Okay. And then we have introduced another set of VAV box. Now this VAV box is on the return side. Okay. What this is trying to do is trying to maintain precise pressurization. If you modulate how much air is going out from that room as well as coming in from the room, you will have very precise reading for pressurization. And that is exactly what we will do for the operating rooms. Operating rooms will usually have 2 VAV boxes, variable air volume boxes. Okay. One on the supply side, one on the return side, to maintain accurate pressurization, accurate controls, accurate laminar flow maintained for that system. Make sense? Okay, so, and again, once it goes back to the air handling unit, the same process repeats again. Okay, any questions on the dual duct systems? Yes.
They will have 2 fans.
Here we have 2 fans. We are talking about the supply and return fan, right? Yes, we do have 2 fans. So for the folks online, the question in the room was, do we have 2 fans in the system? So yes, this is one fan, which is the supply fan. This fan is the return air fan. Any other questions? Any questions from the folks that are online? Okay, if there is no other questions, then yes, please.
So there is a parameter that might consider while doing the time for HU. External static pressure for the design of the system.
Okay, so let me repeat the question for the folks that are online. For the team that is online, the question in the house was, is there a procedure for calculating the external static pressure of a system, correct? Okay, so this is, let's try to have an analogy for it. Okay. Let's say you have a garden hose, right? We have a garden hose for watering the plants and whatnot, correct? The water comes out of the tap, it goes through the pipe or the hose, and then you have a nozzle in front, right? So if the pressure coming into the pipe is less than the pressure that is required outside, the water will not flow, correct? Similarly, if we have a duct, right? That duct, if we are designing at a pressure that the inlet pressure of that duct is less than the outlet maximum point, okay? You'll have hundreds of diffuser, but we are looking at the last diffuser over here. Okay, if that pressure is not met, that last diffuser will be starved of air. There will be no air going. So for calculating that, You start from the first point after the air handling unit, right? If you have a straight duct, that straight duct, as per industry standards, is calculated at 0.08 inches per 100 foot. So if it is 100 foot, the pressure drop will be 0.08 inch. Okay. Let's say you have 10 different accessories. That 10 different accessories of that duct have a pressure drop associated with it. That is defined by another organization like ASHRAE called as SMACNA. Okay. So it is given in that SMACNA guidelines how much pressure drop we consider for these particular accessories. Adding all of those, going all the way up to the last point, we need to add all of those pressure drops to the last point. That is basically the calculation for your external pressure drop. Why external? Because it is external of the air handling unit. When specifying air handling unit, you will also see a total static pressure available for the air handling unit. That means the internal static pressure for all of these components. So when the air goes from this point to this point, this point to this point, it is encountering barriers at every point, right? Like this fan, of course, it is pushing the air, adding to the static. When it comes over here, there is a damper. The air has to overcome the resistance of the damper to move forward, right? Then we have the filters. The filters will end up using the most amount of static in the system. And the higher you go on the MER filter rating, it is harder for the air to go through it, right? Now going from this point to this point also has a pressure drop. This point to this point will also have a pressure drop. So all of that in the air handling unit from this point to this point will be the internal static pressure. What is outside, right? From this all the way up to the last VAV box coming out of the diffuser, that might be over here. That will be your external. Internal plus external will give you a total static pressure available for the air handling unit. When designing that, the fans will come into picture. That is why fans end up becoming a hot topic when it comes to energy analysis. Because the more the pressure drop you have in your system, bigger your fan needs to be, bigger your motor needs to be, and it will consume more power. So trying to have a system that is low on pressure drop, low on air velocity will help us reduce that power usage in the fans. Make sense? Okay. So Peter has a question. Does it supply cold and hot air at the same time? So Peter, I assume you are mentioning regarding the system, the CAV box over here, as well as the air handling unit. Yes, it does have capability of supplying both cold and hot air at the same time. It is at the VAV box that these dampers will modulate to make sure that the supply air temperature from this particular VAV box is set to what is required at this point at the diffuser. So yes, to answer your question, Peter, yes, it will do the same thing, and then it will take care of the supply air temperature that needs to go out of the typical range. Okay, I have a point from Lawrence. I think the ESP, that is the external static pressure calculation, must be done for the critical path. Yes, that is correct. The duct segments and the remotest air terminal and not the air terminal. Lawrence, you're correct. As I mentioned, once the diffuser that goes out, once the air that goes out, we are considering this as the farthest most VAV box. Okay, that is the critical path, farthest most. Okay, because at the end of the day, if you have the hose example that I was talking about, garden hose, if you take a T out of it before the last point, then the last point becomes your critical path, right? So yes, Lawrence, thanks for bringing that up. So we are considering this VAV box to be the critical path, that is the farthest most point that we have in the system. So that will come into consideration. We don't need to consider each and every diffuser, each and every box when we are calculating. All right. Any other questions in the room or online? No? Is everyone asleep already? Don't be, guys. We have just gotten started and I did not finish it today. So what we'll do tomorrow is we'll pick up with these systems, because as I mentioned earlier on in the lecture, I want to make sure that I give you the basics as well, because just teaching you to draw ducts in Revit, that is something that I can do it right away. But understanding what we need to do to draw that duct in the right location, in the right place, is the critical thing that we should properly understand as MEP consultants. All right. Cool. All right then. Thank you so much, Gorky, Emmanuel. All good? Okay. So do I end it or you do end it?
So, thank you for coming for today's session. I hope everyone has enjoyed today's session. So, for those who attended online, please provide your feedbacks about today's session. And for those who are together here physically, I think everyone has enjoyed. Yes? How was today's session? Yes? Interesting?
Give honest feedback. I like, as engineers, we should be open to all feedbacks. It's not the good feedbacks. If you do have it, please let me know. I'll try to incorporate it tomorrow as well as other lectures.
So I think everyone has some different or basic skills about what you have learned today. Yes? So tomorrow we will have a session starting from 3 p.m. as usual, as today's. So please be here on time. Let's try to respect the time and be here on time, because there's some of us came late and we started after some minutes for being late. So tomorrow, let's be here on time. Then we'll start at 3 p.m. as planned. Yes? So, and I hope everyone's computer is with installed software. Yes? Right? Is there anyone who has not yet completing his installation for software? Those who haven't completed the installation for software, please tomorrow come at 2 p.m. to get the support from our support. Yes? Those who have different challenges during the installation, please be here at 2 p.m. to get support. So let me, on the behalf of Nziza, wish you having a wonderful night. Then let's meet tomorrow. Thank you.
Thank you.